IIMK BMS AT, which is the entrance exam for BMS program at IIM Kozhikode, is going to be conducted on 22nd of June 2025. We are coming up with a crash course wherein we will be covering the whole syllabus that is going to be asked in the exam. This crash course is going to have 30 sessions and each session will be delivered to you on this YouTube channel itself daily at 9 pm. After this crash course is done, we will be providing you with the workshops that will definitely help you train for the exam. As of now, we know that the exam is going to have only QA section and VA section. There is no LR section asked in the exam. But the paper pattern of the exam is not known. As soon as we come to know about the paper pattern, we will definitely deliver 3 to 5 mock tests to you guys as well. So make sure that you subscribe to this channel and inform your friends that this course has started and they can benefit from it. And now let us start learning. Hello, I am Aniket from Tarkashastra Academy. In this video, we are going to look at the concepts of numbers followed by some questions. So prerequisite for this session is that you should have watched Tarkashastra basic session 17 and basic session 18. Yeah. So in basic session 17, we have studied about HCF, LCM and classification of numbers. Now we'll be using the concepts of HCF and LCM while solving the questions here. Okay. In numbers 2, we have studied about number system. And it is necessary that before you watch this video, you go to YouTube, search for Tarkashastra basic sessions, and then you will get a playlist in which you have to watch basic session 17 and basic session 18. Only then you will understand the session further. Chalo dekhte hain. Now, one property which you need to understand here is product of two numbers is equal to product of its HCF and LCM. Product of two numbers is equal to its product of HCF and LCM. ठीक है ना? For example, let us say दो number है 24 and 36. ठीक है? If you have watched the video, you will understand this. 24 and 36 का HCF is 12 and LCM is 72. है ना? अगर आपने वो वीडियो देखा होगा तो ये समझ में आएगा. तो ये इक्वल ही है ना? ये इसका 2 इधर दे दूंगा तो ये 24 हो जाएगा और ये 36 हो जाएगा, है ना? So product of two numbers is equal to its HCF and LCM. Product of three numbers is equal to its HCF and LCM. ऐसा नहीं होता. So remember this, that it is only for product of two numbers that it is equal to its HCF and LCM. ठीक है? So now LCM of two numbers is 936. LCM is 936. HCF is 4. HCF is 4. One of the numbers is 72. One of the numbers is 72. Find the other one. And the other one is how much? So this is 72 ones, this is 72. 18 are. So other number will be 18 ones are. This is 18. 5. 36, 2, 52. The other number will be 52. Very easy. Next. 4 bells told together. Now you are expected to pause the video, try the solution yourself. Once you are able to solve it, तो फिर solution देख लो quickly to see if there is any shortcut. अगर आपको नहीं solve होता है तो फिर आप solution देखो, है ना? But पहले खुद से try करना अनिवार्य है. ठीक है? 4 bells told together at 9 am. They told together after 7, 8, 11, 12 seconds. How many times will they told together again in next 3 hours? Simple sign. So total there are 4 bells. Let us see there are only 2 bells. है ना? So first bell and second bell. So they are tolling after 7 seconds and 8 seconds. So this first bell will toll after 7 seconds. Again it will toll after 14 seconds, 21, 28, 35, 42, 49, 56, 63. These are the times. These are the seconds in which it will toll. है ना? And what is this 8 seconds? It will again toll on 16th second, then 24th second, 20, 30 second, 40 second, 48, 50, 56, 64, and so on. है ना? But if you observe, they both are tolling together at a time at 56 seconds. है ना? Now what is this 56? It is LCM of 7 and 8. है ना? 56 is nothing but LCM of 7 and 8. So what do we understand? है ना? They will toll together. They will toll together at the time which is LCM of LCM of tolling interval, है ना? जो कुछ भी आप बोलना चाहो, है ना? They are going to toll after an interval of 7 seconds and 8 seconds respectively. तो उसका जो LCM आएगा, that is their time when they will toll together. Now, when will these four bells toll together? It would be LCM of 8, 7, 11, and 12. This will be the time when they will toll together. So this is how much 2 cube, this is 7 to the power 1, 11 to the power 1. That is 2 square into 3 to the power 1. So LCM will be highest power of 2, 2 cube, highest power of 3, 3 raised to 1, highest power of 7, 7 raised to 1, highest power of 11, 11 raised to 1. So this is 8 into 3 into 7 into 11. So this is 24, 24 into 7 will be 168, 168 into 11. Let us do that. 168 into 11. This is 168, 0, 168. This is 8, this is 4, this is 1, this is 8, this is 1. Okay. So that is 1848 seconds. This is the time when all of them will toll together. This is the time when all of them will toll together. Now, this 1848 seconds is how much? 1848 seconds is how much in terms of minutes? Let us try to gauge that. So 1 minute is 60 seconds. So approximately 1800 seconds will become 30 minutes. This is into 30, no? So this will also get into 30. So this is 30 minutes, 48 seconds. 30 minutes, 48 seconds. So what we can say, after approximately every half an hour, they will toll together. After approximately every half an hour, they will toll together. What are they asking? How many times will they toll together again in next 3 years? So half an hour के बाद they will toll together. 30 minutes के बाद they will toll together. 1 hour के बाद they will toll together. 1 hour 30 minutes के बाद they will toll together. Approximately I'm saying, not exact. Then 2 hours के बाद they will toll together. Then 2 hours and 30 minutes again they will toll together. Then at third hour they will not toll together. Why? Because it is 48 seconds extra, no? Everywhere we have to consider 48 seconds extra. So it will be 3 hours plus some seconds. But we want the time within 3 hours. So that is why we will not consider this sixth one. It will toll together only 5 times in 3 hours. All the bells will toll together only 5 times in 3 hours. Moving forward, two equilateral triangles have the sides of length 34 and 85. Pause the video, try to solve the question. I'll directly continue here. Two equilateral triangles have the sides of length 34 and 85. Then the greatest length of the tape that can measure both of them exactly. So 34 and 85. This is 34, 34, 34. And then you have 85, 85, 85. These are your equilateral triangles. Don't go with the representation. So if I let us say take a scale of 20, so it will become 20 and then 20 will come out here. No? It is not able to measure them exactly. But they are saying that the tape should be able to measure both of them exactly. Now, if I let us say take a scale of 10, so it will be 10, 10, 10, and then this scale will come ahead.
this will be 6, this will be 4. Again, it is not able to measure exactly. What will be the length of the scale which will be able to measure both of them exactly? What will be the length of the scale which will be able to measure both of them exactly? The number which is divisible by 34 and 85. है If the number is divisible by both 34 and 85, then it will be able to measure both the scales exactly. Okay. Now understand one thing. 34 and 85, we have to find out the number which is the factor of 34 and 85, and we also have to find out the greatest of that number. So similarly, we have to find out highest common factor, highest, which is greatest, and then common, a factor which is common for both 34 and 85, common factor. Okay, so we have to find out highest common factor of 34 and 85, which is 2 into 17. This is 5 into 17. So HCF comes out to be 17 raised to 1, which is 17. So if you look at a scale of 17, this will be 17. This will be another 17, 17, 17. If you look at 8, 17 here, 1, 2, 3, 4, 5. 17, 17, 17, 17, 17. Okay, this is how you need to do it. Okay, let us move ahead. A farmer wants to plant 44 apple trees, 66 banana trees, and 110 mango trees in equal rows in number of trees. So let us say he wants to make number of trees in one row to be equal. So if there are, let us say, 15 trees here, then 15 should be here, 15 trees should be here. He also wants to make distinct rows of trees. That is only one type of tree in a row. So let us say if he has apples over here, he cannot have mango or banana. He'll have only apples. And let us say if he has only mangoes over here, then he cannot have apples and bananas like that. Then the minimum number of rows that are required. Now, to get the minimum number of rows, each row should have maximum trees. To get the minimum number of rows. Now we want minimum number of rows. How will we get it? If we have maximum number of trees possible in one row. Okay, if we have maximum number of trees possible in one row. But then there is this condition also that one row should have only tree of one type. Let us say if one row has a tree of banana, no other tree can be there in that row. So what we'll have to do? We anyway we have to find out the maximum number of trees. What we'll do? LCM. These common multiple. We'll find out. These common multiple. Now this is the multiple. No. Maximum we have to find out. We'll find out the HCF. Maximum is nothing but highest. Maximum is nothing but highest. And common factors are the number of trees per row. And the number of trees per row. So we have to find out HCF of 44, 66, and 110. So 44 is 2 into 22, 66 is 3 into 22, and 110 is 5 into 22. HCF will be lowest power of 2, which is 2 raised to 0, lowest power of 3, which is 3 raised to 0, and lowest power of 5, which is 5 raised to 0. And if you have watched that YouTube video, you'll understand that. Then lowest power of 22 will be 22 raised to 1. So HCF is 22. So each row should have 22 trees. Each row should have 22 trees. But now there will be 22 trees in one row. So for apple, I'll need 2 rows. For banana, I'll need 3 rows. And for mango, I'll need 5 rows. 22 into 5 is 110. So like that, I'll need 5 rows. 22 into 3 is 66. So I need 3 rows. So these are the minimum number of rows required. 2 plus 3 plus 5, that is 10. Okay. Look at it properly. Now, find the greatest 5-digit number that will leave a remainder of 5 when divided by 8 and 9. है ना? Let us forget about this greatest 5-digit number. Let us find out the number which will leave a remainder of 5 when divided by 8 and 9. So let us find out a number which is divisible by 8 and 9. So that is LCM of 8 and 9. 8 and 9. LCM of 8 and 9. And if I add 5 to this, if I add 5 to this, and when I divide by 8, the remainder will be 5 because this term will be divisible by 8 and remainder will be 5. If I divide this term by 9, then this term will be divisible by 9 and remainder will be 5. So the condition is satisfied. A remainder of 5 when divided by 8 and 9. Now what is LCM of 8 and 9? 72 plus 5 divided by 8 or 9. See here, when 72 plus 5, 77 is divided by 8, remainder is properly 5. And when 77 is divided by 9, the remainder is again 5. Okay. So we get to know the least number, which is 77. We get to know the least number, which is 77. Now, which will be the next number? If you say 77 ke baad, which will be the next number which satisfies this condition? What is the condition given? A number when divided by 8 and 9 should leave a remainder of 5. So if I double this, it will become 140, 154. Okay. Now when I divide 154 by 8, what I'll get? Remainder as 2. So this condition is not satisfied. I cannot double it over here. And what I'll have to do? I'll have to double this. 72's double is 144 plus 5 when divided by 8 or 9 will leave a remainder of 5. So for example, 144 when divided by 8 will leave a remainder of 0 and 5 divided by 8 will leave a remainder of 5. And 144 when divided by 9 leave a remainder of 0 and 5 divided by 9 will leave a remainder of 5. So what do we understand here? The number should be of the format 72n plus 5. Number should be of the format 72n plus 5. Okay, now what is 72n? It is LCM का multiple. LCM का multiple plus 5. LCM का multiple plus 5. This is what we need to do. Now, let us come to the question. Greatest 5-digit number which will satisfy this condition. So, we'll find out the greatest 5-digit multiple of 72. We'll find out greatest 5-digit multiple of 72. And then we'll add 5 to it. We'll get that number. Yes or no? So simply find out the greatest 5-digit multiple of 72. How do we get that? 99999. This is the 5-digit greatest 5-digit number when divided by 72. What we get? 1 is 72. This is 7. This is 2. This will be 9. 3 is 216. This is 3. This is 6. This is 0. 639. 8 is 72 into 8 kitna? 72 into 8 will be 16 1 carry 56 57 576. So this is 3, this is 6, again 9. 8 is 576. 576. If I divide, this is 3, this is 6. So 9, 5 times 9 or 99999 is not divisible by 72 because it is leaving a remainder of 63. But if I do this 99999 minus 63, this will be 999. This is 6. This is 3. Okay. This will be the number divisible by 72. Divisible by 72, which means it is of this format 72 plus n wala format. And this is also the greatest divisible, greatest multiple of 72, greatest 5-digit multiple of 72. So greatest 5-digit multiple of 72 is 99936 plus 5 will give me the answer when divided by 8 or 9. This will leave a remainder of 0. This will leave a remainder of 5. When divided by 9, again this will leave a remainder of 0 and this will leave a remainder of 5. So 99936 plus 5. My required number is 99941. Okay, required number is 99941. Moving forward, find the greatest four-digit number which when divided by 10, 11, 15 and 22 leaves 3, 4, 8 and 15 as remainder. 3, 4, 8 and 15 as remainder. Okay. Now when divided by 10, the remainder is 3. When divided by 11, remainder is 4. When divided by 15, remainder is 8. When divided by 15, when divided by 22, remainder is 15. Remainder is 15. Now, if you observe, remainder is 3. Also, remainder can be minus 7. For example, 13 divided by 10. Ones are 10, remainder 3. But if I do something like this, 13 divided by 10, 2s are 20, remainder minus 7. So I can say that remainder is minus 7. It is possible. Then 11, when divided by 11, the remainder is 4. So can I say the remainder is minus 7? Yes, I can say that. How am I getting this? 4 minus 11, minus 7. Now when 15 divided by 11, remainder, so 1s are 11, remainder 4. But what if I do something like this? 15 divided by 11, 2s are 22, remainder minus 7. Similarly, 8 minus 15, remainder can be minus 7 here. Remainder can be minus 7 here. So we want to find out the greatest four-digit number, which when divided by these numbers gives the remainder this. So which when divided by these numbers leave a remainder of minus 7 I am saying. Leave a remainder of minus 7 I am saying. So let us first find out the number LCM of 10, 11, 15 and 22. This number will be divisible by 10, 11, 15 and 22. It is similar to previous question. 10, 11, 15 and 22. Okay. Now, if I subtract 7 from this number, I'll get the remainder as minus 7. Which will eventually give me the desired remainder. If I subtract 7 from this number, I'll get the remainder as minus 7. Why? Because this number will be divisible by 10. This LCM will be divisible by 11. It will also be divisible by 15. It will also be divisible by 20. Okay. So when this number is divided by 10, 11, 15 and 22, I'll get the remainder as 0. And this will give me the remainder as minus 7. Which will give me the desired remainders of 3, 4, 8 and 15. So let us find out the LCM of 10, 11. So 10 is 2 into 5, 11 is 11 raised to 1, 15 is 3 into 5, 22 is 2 into 11. So highest power of 2, 2 raised to 1, highest power of 3, 3 raised to 1, highest power of 5, 5 raised to 1, highest power of 11, 11 raised to 1. So this is 6, this is 6, 6 ke baad, this is 30, 30 into 11 is 330. So 330 is that number which is LCM of all these, minus 7 will leave a remainder of minus 7 when divided by 10, 11, 15 and 22. When divided by 10, 11, 15 and 22. ठीक है. Now try to understand this thing. The next number which will satisfy this condition will be multiple of 330 minus 7. Because when divided by 10, 11, 15 and 22, this number again will be divisible by 10, 11, 15 and 22 and will leave a remainder of minus 7. But for that, this number should be divisible by 330. Now come to the question. Greatest four-digit number which satisfies this condition. So we have to find out the greatest four-digit number divisible by 330. Greatest four-digit number divisible by 330. It is very easy to find out. It is 9900. Into 30 karuga. So it will be 9900. This is your greatest 4-digit number. And the next number will be greater than 4. It will have 5 digits. We don't want that. And now from this greatest 4-digit number, I just have to subtract 7. And this number will be divisible by 10, 11, 15, and 22. Okay, 10, 11, 15, and 22. So 9900 minus 7 will be 9893. Okay. Other way to solve this question is working on the options. If this type of question is asked in the exam where there are no options, then we cannot do anything. Then we'll have to go with this linear method. But if the options are provided, directly use the options. Okay. Moving forward, the greatest number which will divide 215, 167, 135, so as to leave the same remainder in each case. Now, understand, let us say there are 3 numbers. One is first ka HCF plus some remainder. Now, other number is HCF ka multiple plus the same remainder, and then third number is HCF ka multiple plus the same remainder. HCF ka multiple and the same remainder. Okay. Now, these are those numbers: 215, 167, and 135. These are those numbers which should leave the same remainder in each case, which when divided by the greatest number, we should leave the same remainder in each case. Now what I do, I'll just multiply, I'll just subtract these two numbers. What I'll get, n1 minus n2 into HCF, the remainder will get cancelled. And I'll also take the HCF, or I'll just subtract these two numbers. It will be n2 minus n3 into HCF, and n2 minus n3 into HCF. Remainder will get cancelled. Now, whatever is the HCF of that number, whatever is the HCF of this number, when divided, now when these numbers are divided by the HCF, then leave the same remainder. Because this term is divisible, this term is divisible, this term is divisible. Everywhere the remainder is same. So as you can see, by subtracting the numbers or by taking the difference of the numbers, we have eliminated the remainder. And whatever number we get, they are multiples of HCF. Whatever number we get, they are multiples of HCF. For example, 215, 167, 135. If I take the difference of these two numbers, it will be 8 and 48. And what is the difference here? This is 32. Now this 32 and 48, are multiples of HCF. And this 32 and 48 are multiples of HCF. Okay, just take 48 and 32 ka HCF. 42 and 38 ka HCF will be 16. And this is 3 into 16. This is 2 into 16. So HCF will be 16. HCF will be 16. Now, this is your HCF. On the basis of this HCF, if you divide these numbers, they'll leave the same remainder in each case. They'll leave the same remainder of 7 in each case. So what we are doing, by subtracting or by taking the difference between the two numbers, we are eliminating the remainder. And then whatever two numbers we get, they are nothing but multiples of HCF. We'll get the HCF of that. That is the greatest number, which when divides those given numbers, will leave the same remainder in each case. Okay. This is when the options are not given. If the options are given, directly use the options. Okay. Let us move forward. The smallest number, which when increased by 6, will be divisible by 36, 63, and 108. The smallest number, which when increased by 6, will be divisible by 36, 63, and 108. So a number is there. It has to be increased by 6. Now this number will be divisible by 36, 63, and 108 all. So what is this number? It is nothing but LCM of 36, 63 and 108. And LCM is what? Least common multiple. And this least common multiple will be divisible by 108, 63, and 36. So what is the least common multiple? 36 is 2 square into 3 square. 63 is 7 raised to 1 into 3 square. 108 is 2 square into 3 cube. So LCM will be highest power of 2, 2 square, highest power of 3, 3 cube, highest power of 7, 7 raised to 1. So this is 4 into 27 into 7. So 4 into 27, 108, 108 into 7 will be 756. So 756 is that number, which is the smallest number, which can which is divisible by 36, 63, and 108. But we want to find out a number which, when added by 6, will give me that number, which is 756. So our number which we need to find out is 750. Answer A. Okay. Moving on, working on factors. So this is easy. Now we'll do the same calculations or same operations on 6, 24, and let us say 150. What are we going to do? Try to understand this. Let us find out the prime factorization. 2 raised to 1 into 3 raised to 1. 24 का prime factorization. 2 cube into 3 raised to 1. 150 का into 3. 2 raised to 1 into 3 raised to 1 into 5 raised to 2. ठीक है. So these are the prime factorizations. अभी prime factorizations आ गए. 6 के factors क्या है? 1, 2, 3 and 6. है ना? 1 is what? 2 raised to 0 into 3 raised to 0. 2 is what? 2 raised to 1 into 3 raised to 0. 3 is what? 2 raised to 0 into 3 raised to 1. 6 is what? 2 raised to 1 into 3 raised to 1. Correct? Now what is sum of the factors? Sum of the factors is 1 plus 2 plus 3 plus 6. If I use these, it is nothing but 2 raised to 0 into 3 raised to 0 plus 2 raised to 1 into 3 raised to 0 plus 2 raised to 0 into 3 raised to 1 plus 2 raised to 1 into 3 raised to 1. Okay. Now, which can be written as 2 raised to 0 plus 2 raised to 1 multiplied by 3 raised to 0 plus 3 raised to 1. It can be written like this. It can be written like this. Yes or no? Sum of the factors. 2 raised to 0 into 3 raised to 0 is this. 2 raised to 0 into 3 raised to 1 is this. 2 raised to 1 into 3 raised to 0 is this. And 2 raised to 1 into 3 raised to 1 is this. So I can simply write sum of the factors. I am not writing as sum of the factors. I am just writing SOF, which is sum of the factors. It is nothing but 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3. 2 raised to 3 तक आ गया into 3 raised to 0 plus 3 raised to 1. इस हिसाब से हम लिख सकते हैं. Similarly, sum of the factors here will be 2 raised to 0 plus 2 raised to 1, 3 raised to 0 plus 3 raised to 1 multiplied by 5 raised to 0 plus 5 raised to 1 plus 5 raised to 2. And this is how you calculate sum of the factors. Then number of factors. Number of factors. This bracket has 2 terms, or here you have 1. So 1 plus 1, 2. This bracket has 2 terms, or here you have 1. So 1 plus 1, 2. Total number of factors 4. If we see number of factors, this is 3 plus 1, that is 4, or number of terms in this bracket are 4, and this is 1 plus 1, that is 2, or number of terms in this brackets are 2. So total number of factors for 24 are 8. Then 150, number of factors. This is 1 plus 1, 2. This is 1 plus 1, 2. This is 2 plus 1 3. So total number of factors are 12. ठीक है, total number of factors are 12. Write this down. है ना, write this down. I'll be erasing some part of it. Okay, I'll be erasing some part of it. So this is how you can find out sum of the factors and number of factors. Now I'll be erasing some part of it. तो बाकी का लिख के रखो. Okay. So what we had, sum of the factors as 2 raised to 0 plus 2 raised to 1 into 3 raised to 0 plus 3 raised to 1. Now, what is the sum of even factors? Now, try to understand this. Even or odd is always decided by 2. If a number is multiplied by 2 or multiple of 2, then it is an even number. If a number is not multiplied by 2 or multiple of 2, then it is an odd number. है ना? So if you see, only this bracket will decide whether the number is even or not. This bracket has no rule in it. है ना? So what we do? Out of 2 raised to 0, 2 raised to 1, even number is 2 raised to 1. We write that. And this bracket as it is, 3 raised to 0 into 3 raised to 1. Okay. Number of even factors will be here you have only one term. Here you have two terms. 1 into 2. You can see there are two even factors. Now, what is the sum of odd factors? Sum of odd factors. Now, 2 raised to 0 and 2 raised to 1. As I told you, even and odd will be decided by 2 and the bracket of 2. Now, this is the only odd term 2 raised to 0 over here. So, we'll write 2 raised to 0 into 3 raised to 0 plus 3 raised to 1. 3 raised to 0 plus 3 raised to 1. 3 raised to 0 plus 3 raised to 1. Okay. 3 raised to 0 plus 3 raised to 1. ठीक है. Now, number of odd factors क्या आएगी? है ना? This bracket has one term. This bracket has two terms. So number of odd factors हमारे दो आए. Okay. So here sum of even factors कितना आएगा? Sum of even factors. These are your even terms. So write those down. 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3. And this bracket has no rule. We write it as it is 3 raised to 0 plus 3 raised to 1. Number of even factors कितने आ जाएंगे? यहाँ पे 3 terms है, यहाँ पे 2 terms है. So 6 factors out of total 8 factors, 6 factors will be even. Number of the sum of odd factors क्या आएगा? This is the only term which is odd, so write that down. And next bracket as it is, so 3 raised to 0, 3 raised to 1. Number of odd factors कितने हो जाएगी? Number of terms over here are 1, here are 2. And total of odd factors will be 2. Okay, try to do the same for 150. So for 150, sum of even factors. Sum of even factors. This is the only even term. So write 2 raised to 1. And then remaining terms as it is. 3 raised to 0 plus 3 raised to 1 into 5 raised to 0 plus 5 raised to 1 plus 5 raised to 2. And a number of even factors will be, here we have one term, here we have two terms, here we have three terms. So total 6 even factors. Sum of odd factors. So this is the only odd term over here. So write that down, 2 raised to 0, then 3 raised to 0 plus 3 raised to 1, 5 raised to 0 plus 5 raised to 1 plus 5 raised to 2. Okay. So odd factors. Number of odd factors will be how much? odd factors will be one term here, two terms here, three terms here. Total 6 odd factors. है ना? So I hope you have understood how to calculate sum of factors, number of factors, sum of even factors, number of even factors, and sum of odd factors and number of odd factors. है ना? Let us try to implement it over here. 2450. है ना? Let us try to implement it over here. 2450. And then DEF. I'll explain it. So pause the video and try to solve it. So 2450 is nothing but 245 into 10. So that is 5 raised to 1 into 7 square into 2 raised to 1 into 5 raised to 1. So 2 raised to 1 into 5 raised to 2 into 7 raised to 2 is this is the prime factorization. Now sum of the factors will be 2 raised to 0 plus 2 raised to 1, 5 raised to 0 plus 5 raised to 1 plus 5 raised to 2, and then 7 raised to 0 plus 7 raised to 1 plus 7 raised to 2. Now this is not the final answer. You'll have to calculate it. What is 2 raised to 0? 1 plus 2. This is 1 plus 5 plus 25. This is 1 plus 7 plus 49. So which is 3 into 31 into 57. Whatever is the answer is going to be the final answer. Right? So 3 into 31 is 93. 93 into 57. 1s are 21. This is 63, 65, 0. This is 15, 1 carry. This is 45, 46. This is 1, this is 0, this is 1. This is 3, 1. 5, 3, 0, 1. 5, 3, 0, 1 is going to be the sum of the factors. This is your final answer. I am leaving it here. Till now I left it till here. But this is your final answer. Okay. Number of factors will be 2 terms over here, 3 terms here, 3 terms here. So 18 number of factors. Next, sum and number of even factors. Sum of even factors. Even matlab only this is the even term. बाकी तो हम वैसा लिख देते हैं. 5 raised to 0, 5 raised to 1 plus 5 raised to 2. 7 raised to 0 plus 7 raised to 1 plus 7 raised to 2. You'll have to solve it. I am not solving it now. You'll have to solve it. Number of even factors will be how much? 1 into 3 into 3, that is 9. Then sum of odd factors will be 2 raised to 0. This is the only odd term over here. 2 raised to 0 into 5 raised to 0 plus 5 raised to 1 plus 5 raised to 2 into 7 raised to 0 plus 7 raised to 1 plus 7 raised to 2. As it is. Number of odd factors will be 1 into 3 into 3, that is 9. 1 into 3 into 3, that is 9. Okay. Now the sum and number of factors divisible by 5. Sum and number of factors divisible by 5. Now for a factor to be divisible by 5, it should be multiplied at least by 5 or multiple of 5. It should be multiplied at least by 5 or multiple of 5. So I cannot have 5 raised to 0 over here, because if multiplied by 5 raised to 0, that number will not be divisible by 5. So factors divisible by 5. What they will be? 2 raised to 0 plus 2 raised to 1. 5 raised to 1 plus 5 raised to 2, because I am eliminating 5 raised to 0. Again, I am telling you 5 raised to 0 is, if multiplied by 5 raised to 0, that factor will not be divisible by 5. And then 7 raised to 0, 7 raised to 1, 7 raised to 2, 7 raised to 0, 7 raised to 1, 7 raised to 2. And number of factors divisible by 5 will be 2 into 2 into 3, that is 12. Next is factors divisible by 35. 35 is 5 raised to 1 into 7 raised to 1. Yes or no? 35 is 5 into 7. So minimum we need 5 raised to 1 into 7 raised to 1. Okay, so minimum 5 raised to 1 into 7 raised to 1 chahiye. So we'll have to go 5 raised to 1, 5 raised to 2 will do, 7 raised to 1 and 7 raised to 2 will also. So what is this? it would be 2 raised to 0, 2 raised to 1. There is no say of 2 in this, no. We are working only with 5 and 7. Then 5 raised to 1 plus 5 raised to 2 and 7 raised to 1 plus 7 raised to 2. All these factors will be divisible by 35 because minimum 35 will come over there. And number of factors will be 2 into 2 into 2. That is 8. 8 factors will be divisible by 35. And factors divisible by 245. Now 245 is 5 raised to 1 into 7 raised to 2. And 49 5s are 245. So it will be 49 5s are 2 raised to 49 5s are 245. Now I need minimum 5 raised to 1 and minimum 7 raised to 2. So simple, 2 raised to 0, 2 raised to 1. And nothing is said about 2 or multiple of 2. We'll take it as it is. Minimum 5 raised to 1 is needed to 5 raised to 1, 5 raised to 2. And minimum 7 raised to 2 is needed to 7 raised to 2. Number of factors will be 2 into 2 into 1. That is 4 factors will be divisible by 45, 245. Okay, I hope it is clear to you. Okay, moving forward. The number of divisors of 1080 excluding the divisors which are perfect square. Excluding the divisors which are perfect square. Let us first find out the number of divisors. 1080 is 36 3s are into 10. No. So this is 2 square into 3 cube into 2 raised to 1 into 5 raised to 1, which is 2 raised to 3, 3 raised to 3, 5 raised to 1. Sum of the factors क्या आ जाएगा? 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3. 3 raised to 0 plus 3 raised to 1 plus 3 raised to 2 plus 3 raised to 3 into 5 raised to 0 plus 5 raised to 1. ठीक है. So number of factors कितने आ जाएंगे? First bracket has 4 terms, second bracket has 4 terms, third bracket has 2 terms. So 16, 32 number of factors. But now we have to exclude the factors which are perfect square. है ना? तो perfect square factors क्या है हमारे? Perfect square factors. We have 2 raised to 0, then 3 raised to 0, 2 raised to 2. है ना? These two are not perfect square. 2 raised to 1 and 2 are not perfect square. Then 3 raised to 0, 3 raised to 2 are perfect square. 3 raised to 0 plus 3 raised to 2 are perfect square. And then 5 raised to 0. And then 5 raised to 0. So perfect square factors are 2 into 2 into 1. That is 4. 2 into 2 into 1. That is 4. So total number of factors are 32. उसमें से perfect square factors are 4. So factors excluding perfect square factors will be 32 minus 4. That is 20. Simple example. Next, find the number of divisors of 544 excluding this. So 544 बोला है. 544 ऐसा ही करते हैं. 544 divided by 2. 250 plus 22, 272. Again divided by 2, 136. Again divided by 2, 68. Again divided by 2. Again divided by 2, 34. Again divided by 2, 17. 17 से नहीं जाएगा तो 1. So 544 is 2 to the power 5. So no, 2 to the power 5 into 17 to the power 1. Okay. Now sum of the factors. Let us try to find out that 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 plus 2 raised to 4 plus 2 raised to 5 multiplied by 17 raised to 0 plus 17 raised to 1. Now number of factors. Now number of factors will be how much? Here you have 6 terms, here you have 2 terms. So 6 into 2, 12 by the number of factors. Now we want to find out number of factors 1 excluding 1 in itself. So 1 and 544 को exclude करना है मुझे. So total number of factors excluding 1 in itself will be 10. है ना? Then factors which are greater than 3. तो 544 के फैक्टर में 1 आएगा, 2 आएगा, फिर 4 आएगा एंड सो ऑन. I just have to eliminate 1 and 2. I just have to eliminate 1 and 2. So out of 12, I have to eliminate 1 and 2. Remaining all the factors will be greater than 3. तो ये वाला में 10 ही आएगा. Then factors which are perfect square. So perfect square factors कौन से? Perfect square 2 raised to 0, 2 raised to 2, 2 raised to 4, and then 17 raised to 0. ठीक है, तो 3 into 1, तो टोटल देगा 3 perfect square factors and factors which are odd. Odd मतलब यहाँ पे मेरे को सिर्फ 2 raised to 0 लेना पड़ेगा, है ना, sum of odd factors देता हूँ फिर, तो यहाँ पे पहले मुझे सिर्फ 2 raised to 0 लेना पड़ेगा because remaining all the terms are even, and then 17's bracket has no say, we write it as it is. So 1 into 2, number of factors which are odd are 2. Simple enough. Okay. Moving forward. Now, number of zeros in an expression. This is very important. Number of zeros in an expression. ठीक है. A zero is formed when it is multiple of 10. है ना? I take any number 3, 4, 2. If I have 1 0 over here, it means it is multiple of 10. है ना? If I have 4, 3, 7, 0, 0, means it is multiple of 100. है ना? If I have 3, 9, 0, 0, 0, it means it is multiple of 1000. है ना? So number of tens we can find out in an expression, will be able to find out the number of zeros. So number of zeros is nothing but number of tens, and number of tens we can find out. अभी 10 find out करना है, मतलब वो 10 जरूरी नहीं है लग के ही आए, है ना? It can be 2 raised to 1 into 5 raised to 1, है ना? It can be 2 raised to 1 into 5 raised to 1, है ना? Now let us say 62 into 25 into 43 into 24, है ना? Now I'll get 5 raised to 2 from here, I'll get 2 raised to 3 from here, and I'll get 2 raised to 1 from here. I'll get 2 raised to 1 from here. So total I have 2 raised to 4 and I have 5 raised to 2. Now how many pairs of 2 and 5 I can make? I can make only 2 pairs of 2 and 5, है ना? Which is 10 to the power 2. Means this number has 2 zeros in the end. Means this number has 2 zeros in the end, है ना? This number has 2 zeros in the end. Okay, this is how you find out the number of zeros in an expression. Let us try to find out the number of zeros in this expression, and then we'll move to the factorials. So what we have, 13 into 15. So 15 will give me 1, 5. 22 will give me 1, 2. 125 will give me 5 to the power 3. 44 will give me 2 to the power 2. And 35 will give me 5 to the power 1. So how much I have? 5 to the power 1, 5 to the power 2, 5 to the power 5. So I have 5 to the power 5. And then I have 2 to the power 1 and 2 to the power 3. 2 to the power 2. So that is 2 to the power 3. How many pairs of 2 and 3 I can make? 2 into 5 to the power 3. Which means this expression is multiple of 10 cube, which means it should have 3 zeros in the end. And this expression should have 3 zeros in the end. And this expression should have 3 zeros in the end. Okay, this expression should have 3 zeros in the end. Okay. Now let us try to find out number of zeros at the end of a factorial value. So for example, let us say I want to calculate for the number of zeros in 54 factorial, let us say. Number of zeros in 54 factorial. Now 54 factorial is 1 into 2 into 3, 5, then 10, somewhere 15, 20, 25, something up to 54 factorial. Now I want to find out number of zeros at the end of factorial level. Means I want to find out highest power of 10. For that I need 2 into 5 to the power of n, highest power of n. So how many 2's and how many 5's can I get? That is what I need to find out. So this 2 will give me 1, 2. Then I have 4. This will give me 1, 2. And then I have 6. This will give me 1, 2. And then I have 8. This will give me 1, 2. And still 54. 54. So every even number will give me, every multiple of 2 will give me 1, 2. So that is 2 raised to 27. Total there are 54 numbers, है ना, of which 27 are even, है ना, so I get 2 raised to 27. Now with 4 I get one more 2, with 8 I get one more 2, with 12 I get one more 2, है ना, till like 52 I get one more 2, है ना. Why? Because these are multiples of 4 and each 4 will give me 1 2 extra, and each 4 will give me 1 2 extra. So how many multiples of 4 will have? 13 multiples of 4 will have. So 2 raised to 13. Now each multiple of 8 will give me 1 2 extra. Each multiple of 2 will 8 will give me 1 2 extra. So 8 will give me 1 2. 16 will give me 1 2 extra. Then 24 will give me 1 2 extra and so on. है ना? So total number of 2's that any expression can have maximum. ये हम कैसे निकालेंगे? This is the logic behind it. This is the shortcut behind it. 54 divided by 2, तो ये 27 आया. 54 plus, है ना, this is your 54. 54 divided by 4, quotient is 13. Then 54 divided by 8, है ना, मैं क्यों कर रहा हूँ? This is 2 raised to 1, this is 2 raised to 2, this is 2 raised to 3, this is 2 raised to 3. So 54 divided by 8, it's 6. Then 54 divided by 2 raised to 4, that is 16. Those are 3. And 54 divided by 2 raised to 5, that is 32. That is 1. And 27 plus 13, 40. 40 plus 10, 50. है ना, तो highest power of 2, है ना, highest power of 2 is 2 raised to 50. है ना, मैं क्या बोल रहा हूँ, इसको ध्यान से सुनो. Highest power of 2. Highest power of 2 is 2 raised to 50. Highest power of 2 is 2 raised to 50. ठीक है. Highest power of 2 is 2 raised to 50. Similarly, can I find out the highest power of 5? वो भी हम same method से निकालें. 54 divided by 5. 54 divided by 5 square. 54 divided by 5 square. And 54 divided by 5 cube. And so on. 54 divided by 5, ये 10 है. 54 divided by 5 square, ये 2 है. 54 divided by 125, ये तो 0 है. So highest power of 5 is 5 to the power 12. Highest power of 5 is 5 to the power 12. Now 2 to the power 50 and 5 to the power of 12. 2 and 5 के मैं कितने पेयर्स बना सकता हूँ? 2 and 5 के मैं मैक्सिमम 12 पेयर्स बना सकता हूँ. 2 and 5 के मैं मैक्सिमम 12 पेयर्स बना सकता हूँ, है ना. अभी 2 and 5 के अगर मैं मैक्सिमम 12 पेयर्स बना सकता हूँ, तो हाईएस्ट पावर ऑफ 10 is 10 raised to 12, which means it will have 12 zeros in the end. It will have 12 zeros in the end. ठीक है? Here's how you need to do it. ऐसा करना पड़ेगा. ठीक है? I'll give you some more examples. You will understand. ठीक है? Let us try to find it. 58 factorial. 58 factorial. 58 factorial. What I'll do? 58 divided by 2 plus 58 divided by 4, because it is 2 square. Then 58 divided by 8, 2 cube. 58 divided by 16, 58 divided by 32, and 58 divided by 64. तो ये तो 0 आ जाएगा, है ना. यहाँ पे 1 आएगा, यहाँ पे 3 आएगा, यहाँ पे 7 आएगा, यहाँ पे 52 56 ना, तो 14 आएगा, एंड ये 29 आएगा, है ना. 29 plus 14, 43, 50, 54, है ना, 54. तो 2 raised to 54. This is the highest power of 2, है ना, highest power of 2. ठीक है. Then highest power of 5 will find 58 by 5, 58 by 25, 58 by 125, and so on. This will be 0. This will be 2. 58 by 25. Quotient is 2. And then 58 by 5. This is 11. So we have 5 to the power 13. Highest power of 5. Now with 2 and 5, how many pairs of 2 and 5 I can make? 2 into 5. Maximum 13 5s I have. So I will take 13 2s. Remaining 2s are wasted. Okay. So this is nothing but 10 to the power 13. This is nothing but 10 to the power 13. So it will have 13 zeros in the end. This will have 13 zeros in the end. है ना? Now you must have observed number of fives are always less than number of twos. या फिर highest power of 5 or greatest power of 5 is always less than greatest power of 2. Greatest power of 5 is always less than greatest power of 2. Here you had 5 raised to 13 and here you had 2 raised to 54. Here you had 5 raised to 12 and you had 2 raised to 50. So greatest power of 5 is always less. Yes, because 5 contributing numbers are also less. No? Till the time I get 1 5, I get 2 threes, 3 twos. Till the time I get 5 raised to 1, I get 2 raised to 3 already. So number contributing 5 are much higher, much lower. So what we can do, only if I find out highest power of 5, we will be able to find out the number of zeros in the expression. Let me explain you how. So 173 factorial. 173 divided by 5. 173 divided by 25. 173 divided by 125. 173 divided by 625 and so on. So this will be 0. This is 1. This is 6. And this is 3. 34. So 41. Total is 41. Highest power of 5 is 5 raised to 41. Will I have highest power of 2 greater than 41? Yes. 2 raised to 41 तो minimum मिल ही जाएगा मेरे को. 2 raised to 41 तो मिल ही जाएगा. If in 58 factorial I have 2 raised to 54, in 173 factorial I definitely have more than 2 raised to 54. So, but how many twos I need? Only 41 twos I need because I have only 41 fives. So, how many pairs of twos and 5 I can make? 41. Which is 10 to the power 41, which will have 41 zeros in the end. This thing will have 41 zeros in the end. Now try to understand here. We have just found out the highest power of 5. And we already know that highest power of 2 is going to be greater than highest power of 5. Or what we are saying, we know that the number of 5s are 41. And the number of 2s will definitely be greater than 41. So no need to calculate that. Only on the basis of highest power of 5, we will be able to find out the number of zeros in the expression. So for question number D, E, F, we will find only highest power of 5. So D is how much? 1098 factor. So that is 1098 divided by 5. 1098 divided by 25. 1098 divided by 125 and 1098 divided by 625. We cannot go further. So this is 1, this is 8, 1098, 25, 4, 40, 43, and this is 2, 1, 2, 1, 9. There कुछ calculation mistake नहीं. ठीक है. So 219 plus 43 is 262, 262, 270, 271. So this is 271. So highest power of 5 is 271. Will I be able to get highest power? Will I be able to get sufficient 2s? Yes. Because highest power of 2 will always be greater than highest power of 5. So I will always have more 2s than more 5s. Okay. So with this, I'll be able to make 10 raised to 271, which gives me 271 zeros. Next, what you have? 1132 factorial. So that is 1132 divided by 5, 1132 divided by 25, 1132 divided by 125, 1132 divided by 625. So 1132, 1132, this is 1. This is 1132, no? This will be 9. This is 40, 44, 45. This will be 200, 130 divided 26, 230, 226. 226 plus 9 is 235. 235 plus 45 will be 280. 281. So highest power of 5 is 281. I'll definitely have highest power of 2 greater than 281. So I'll definitely have sufficient number of 2. With this, I'll be able to make 10 raised to 81, which is 281 zeros. 281 zeros in the end. Next is 1142 factorial. 1142 factorial. Let us try to find out the number of zeros in 1142. 1142 divided by 5. 1142 divided by 25. 1142 divided by 125. 1142 divided by 625. ठीक है. So ये कितना आ जाएगा? This will be 1. This will be 9. This will be 45. And this will be 228. So this is 283. Highest power of 5, 283. I'll definitely have sufficient number of 2's, which will give me 10 to the power 283 is equal to 283 zeros. Yeah. So you have 283 zeros here. Yeah. Then 348 factorial. So 348 divided by 5. 348 divided by 25. 348 divided by 125. And so on. So this is 6 and this is 9. This is 25. This will be 15, 16, 25, 13 in fact. And then this will be 2. So 71, 84. So highest power of 5, 5 raised to 84. 2 raised to 84 to मिल ही जाएगा. Highest power number of tens will be 84. Number of zeros 84. And 17 factorial में 3 zeros मिलेगी, है ना, क्योंकि 5 क्यूब आएगा. So this is nothing but the highest power of 5, which is 5 to the power 283 या फिर 10 to the power 283, है ना, into 10 to the power 84 into 10 to the power 3. So 83, 86, 90, 290, 370, 10 to the power 370. 10 to the power 370 means this expression will have 370 zeros in the end. This expression will have 370 zeros in the end. ठीक है. Moving forward, n factorial has 23 zeros. What is the maximum possible value of n? N factorial has 23 zeros. What is the maximum possible value of n? तो n factorial पहले b वाला क्वेश्चन करते हैं. b वाला थोड़ा सिंपल. n factorial has 13 zeros, है ना. तो 13 zeros मिलने के लिए मेरे को 5 पे 1 मिलेगा. 5 पे 1 मिलेगा. फिर 10 पे दूसरा 5 मिलेगा, है ना. 13 zeros मतलब 10 to the power 3 है, 10 to the power 13 है, which means 2 to the power 13 into 5 to the power 13 है. So highest power of 5, highest power of 5 is 13. ठीक है. Highest power of 5 is 13. So I am calculating number of 5s where I will get. So 15 में मुझे 5 raised to 1 मिलेगा. 20 में मुझे 5 raised to 1 मिलेगा. 25 में मेरे को 5 raised to 2 मिलेगा. So 25 factorial में मेरे को 5 raised to 6 मिलता है. Similarly 50 factorial में फिर 5 raised to 12 मिल जाएगा. 50 factorial में 5 raised to 12 मिल जाएगा. 55 factorial में मेरे को 5 raised to 13 मिल जाएगा, है ना. 55 factorial में 5 raised to 13 मिल जाएगा. As soon as I get 5 raised to 13, I'll have 10 raised to 13, which will give me 13 zeros. So 55 factorial, n is equal to 55 factorial. This is the least value that is needed to get. This is the least value that is needed to get 5 raised to 13, which will give me 10 raised to 13, which will give me 13 zeros. But if I have 56 factorial, still I will have 13 zeros क्योंकि 5 नहीं आया. 57 factorial भी रहा, Still I have 13 zeros only. 58 factorial also I'll have 5 zeros. 59 factorial again I'll have only 13 zeros. 60 factorial I'll have 14 zeros. I don't want. So this is the highest value. And 55 factorial is also giving me 13 zeros, and 59 factorial is also giving me 13 zeros. So these are the least and highest values of n. Okay, write this down. I'll be erasing it. A part. Now n factorial has 23 zeros. And what is the maximum possible value of n? So as I know, 25 factorial gives me 5 raised to 6. 50 factorial will give me 5 raised to 50 factorial will give me 5 raised to 12. 75 factorial will give me 5 raised to 18, and 100 factorial will give me 5 raised to 24. We want 23 zeros. 23 zeros means 10 raised to 23 means 2 raised to 23 into 5 raised to 23. So 5 highest power is 5 to the power 23. So 100 factorial has 5 raised to 24. What will 99 factorial have? It will have 5 raised to 22 only, because this 100 was contributing 5 raised to 2. No? This 100 was contributing 5 raised to 2. Yes or no? This 100 was contributing 5 raised to 2. That is why we got 5 raised to 24. Now, if I remove that 100 and I use only 19 factorial, I'll have 5 raised to 22. So 5 raised to 23 is not possible. 5 raised to 23 is not possible. So maximum possible value of n is cannot be determined. Maximum possible value of n is cannot be determined. Okay, I hope it is clear. Simple cycle. I hope it is clear. Okay, moving forward. Last 4 questions. What is the highest power of 7 which divides 81 factor? Highest power of 7 which divides 81 factor. Simple. Similarly, as you found out highest power of highest power of 5, you will find out highest power of 7. So 81 divided by 7 plus 81 divided by 49, which is 7 square. Then 81 divided by 343, which is 7 cube. तो ये तो नहीं आएगा, ये तो 0 आएगा, ये 1 आएगा, ये 11 आएगा. So this is 12. So highest power of 7 is 7 raised to 12. Then highest power of 11, which divides 91 factorial. So 91 divided by 11, 91 divided by 121. 11 square, not possible. 91 divided by 11 is 8. So highest power of 11 is 11 to the power 8, which properly divides 91 factorial. Now 21, highest power of 21, which divides 122 factorial. So 122 divided by 21. So 122 divided by 21 plus square, 441. And you do this, 21 5s are 105. So highest power of 21 is 21 raised to 5. If you do this and you tell me this answer, this is wrong. Remember that this is wrong. Why? Just like 10 was made using 2 into 5. 21 is made using 3 into 7. So 21 is made into 3 into 7. Now in 122 factorial, I'll have to find out highest power of 3 and highest power of 7. Obviously, highest power of 7 will be much lesser than highest power of 3. Yes or no? है ना, चलो मैं करके दिखाता हूँ. Highest power of 3, 122 by 3, 122 by 9, 122 by 27, 122 by 81. So 122 by ये 120 मतलब 40 आ गया यहाँ पे 120, तो this is 90, 13 आ गया यहाँ पे and 4 आ गया 1. So this is 45, 58. So 3 to the power 58. Highest power of 7 कितना है? 122 by 7, 122 by 49, and 122 by 343, which will give me 0. तो ये कितना है 2 and ये 7 7 17, तो टोटल 90. तो हाईएस्ट पावर ऑफ ये कितना है 7 7 to the power 90. As I told you, just like 5 का पावर highest power is always less than 2 का highest power. Similarly, 7 का highest power will always be less than 3 का highest power. So number of sevens, whatever we get the number of sevens as, we will definitely get number of threes that much. है ना? Number of sevens जितने भी आते हैं, definitely will get number of threes that much. Correct? है ना? Remaining threes are already wasted, and we know that number of sevens are going to be lesser than number of threes. Why? Because 7 contributing numbers are lesser than 3 contributing numbers. Okay, so total we will have 21 to the power 90 and not 21 to the power 5. So highest power of 21 that can divide 122 factorial, it's 21 to the power 90. 21 to the power 90. Next, find the highest power of 15 which divides 520 factorial. अभी 15 is made of 3 into 5, है ना? So 5 का मैं highest power निकाल लेता हूँ, 3 का भी उतना ही मेरे को मिल जाएगा, तो मेरे को 15 का मिल जाएगा, है ना? 3 का भी मेरे को उतना ही मिल जाएगा. चलो इरेज इट, फिर सॉल्व करते हैं. 15 है, 15 is 3 into 5, है ना? अगर मैं हाईएस्ट पावर ऑफ 5 निकालता हूँ तो हाईएस्ट पावर ऑफ 3 निकालने की मेरे को जरूरत नहीं है. क्यों? क्योंकि नंबर ऑफ 5 विल ऑलवेज बी लेस देन नंबर ऑफ 3 एंड जितने भी नंबर ऑफ 5 है उतने सफिशिएंट नंबर ऑफ 3 मुझे मिल जाएंगे. ऐसा क्यों? बिकॉज 5 कंट्रीब्यूटिंग नंबर्स आर लेसर देन 3 कंट्रीब्यूटिंग नंबर्स, है ना? दैट इज व्हाई इट विल बी 520 by 5, 520 by 25, 520 by 125, and 520 by 625, which will give me 0. So this is 4, this is 20, this is 1, 0, 4. So how much I have? 128. So highest power of 5 is 5 to the power 128. Will I get sufficient threes? Yes, I'll definitely get sufficient threes. Why? Because number of threes are greater than number of fives. Because 3 contributing numbers are much higher than 5 contributing numbers. So this will give me 15 to the power 128. So highest power of 15 that can divide 520 factorial is 15 to the power 128. Okay. So this was our numbers 1. We are done with it. If you have any query, you can connect on any of these 3 social media platforms or visit our website tarkashastra.co.in or send a WhatsApp message on any one of these 2. In this video of numbers 2, we are going to look at the concepts of divisibility rule, cyclicity, and also the remainder theorem. ठीक है ना? तो ये सारा कुछ हम देखने वाले हैं. डिविजिबिलिटी रूल्स. तो डिविजिबिलिटी रूल्स तो एकदम सिंपल से रहते हैं हमारे. 2 की डिविजिबिलिटी, लास्ट डिजिट डिविजिबल बाय 2, है ना? 2:1 में लास्ट डिजिट, 2:2 दैट इज 4. तो यहाँ पे लास्ट 2 डिजिट्स मस्ट बी डिविजिबल बाय 4, है ना? लास्ट 2 डिजिट्स मस्ट बी डिविजिबल बाय 4, है ना? कंसिडर एनी नंबर 3824932, है ना? Can I write it like this? 3824900 plus 32. Now 100 is divisible by 4. Yes or no? 100 is divisible by 4. So obviously all the multiples of 100 will be divisible by 4. Obviously all the multiples of 100 will be divisible by 4. So this value will be divisible by 4. Now only this value will decide whether this whole number is divisible by 4 or not. And that is the last 2 digit subject. Then 2 cube is 8. Here we check last 3 digits should be divisible by 8. Taking this number only. Can I write it like this? 3824000 plus 932. 1000 is divisible by 8. So obviously this multiple of 1000 will be divisible by 8. So only last 3 digits will decide whether the complete number is divisible by 8 or not. And that is why for the divisibility rule of 8 is last 3 digits of the number should be divisible by 8. And similarly 2 raised to 4 is 16. तो इसमें हम देखेंगे last 4 digits should be divisible by 16. Next is 3. Sum of the digits must be divisible by 3. 9. Sum of the digits must be divisible by 9. If this is the number, if the sum of the digit is divisible, this is the number. If the sum of the digits means 3 plus 8 plus 2 plus 4 plus 9 plus 3 plus 2, something like that. How much is this? This is 11 plus 2. 11 plus 2, 13, 17, 26, and 31. So it is not divisible. 31 is not divisible by 3. So this whole number is not divisible by 3. 31 is not divisible by 9. So this whole number is not divisible by 9. Like that. Then 5 की divisibility, last digit 0 or 5. अगर end में 0 या फिर 5 आता है, then that number is divisible by 5. Divisibility of 10 will be last digit should be 0. If the last digit is 0, then the number is divisible by 10. Divisibility of 11. Write this down. Difference of sum of the digits at even place to sum of digits at odd place should be 0 or 11 or 22 or multiple of 11. उसको ठीक है. So what do we understand by this? ठीक है, let us say there is this is the number. I want to check whether this number is divisible by 11 or not. So what I'll do, sum of the digits at odd places. So 3 plus 6, 9 plus 8, 17 plus 1, 18. Sum of the digits at odd places. And sum of the digits at even places. 5 plus 4, 9 plus 2, 11 plus 7, 18. If this difference is equal to 0, difference ही निकालना है ना. This is sum of the digits at odd places. This is the sum of the digits at even places. We want to find out the difference of sum of the digits at even places and sum of the digits at odd places should be equal to 0 or 11 or 22. So here the difference is of 0. So this whole number will be divisible by 11. Okay, I hope it is clear. So these are the divisibility rules of 2, 4, 8, 16, 3, 9, 5, 10, 11. Now there are few more numbers jiska we have to check the divisibility rule. First write this down. I'll be erasing the screen and then we'll be looking at the divisibility of those numbers. Okay, so before going forward with the divisibility of those numbers, let us try to understand what are co-prime numbers. And co-prime numbers we have studied it in the basic session. So before numbers 1 session, you have to go through the basic sessions on our YouTube channel. So in that YouTube channel, we have told about the co-prime numbers. So co-prime numbers, they have only one common factor, that is 1. One common factor, that is 1. Those are your co-prime numbers. Okay. Now, what is the divisibility rule of 6? If the number is divisible by 2 and 3, both, then the number will be divisible by 6. What I'm saying, if the number is divisible by 2 and also by 3, then the number will be divisible by 6. Okay. So we know the divisibility rule of 2. Last digit should be divisible by 2. We also know the divisibility rule of 3, that sum of the digits should be divisible by 3. Now, what did we do here? the product of these two, 2 into 3 is equal to 2 into 3 is equal to this number 6, and this 2 and 3 are co-prime to each other because they have only one common factor, which is 1. For example, let me say I have to find out the divisibility rule of 12. So it can be 2 and 6, it can be 3 and 4. But if it is 2 and 6, even though the product of 2 and 6 is 12, but 2 and 6 are not co-prime to each other. And they have more than one common factor, which is 2. And if you are not understanding what is co-prime number, go to the basic session 1. Basic session numbers 1 ka basic session, which is basic session 17, I guess. Go there, check what are co-prime numbers. There I have explained it in detail. Key co-prime numbers, how they function. So 2 and 6 are not co-prime numbers. Now 3 and 4, it is satisfying both the criteria. 3 into 4 is equal to 12, and 3 and 4 are co-prime to each other. For example, 15. 15, it should be 3 and 5. Product of 3 and 5 is 15, and 3 and 5 are co-prime to each other. 24. Now you can see 6 and 4, 8 and 3. But then 6 and 4, even though product of 6 and 4 is 24, but they are not co-prime to each other. 8 and 3, product is 24 and they are co-prime to each other. So what are we trying to say here? If the number is divisible by 8 and also by 3, then that number will be divisible by 24. There are many cases like 45. So 5 and 9. And if the number is divisible by 5 and 9, then the number will be divisible by 45. Why? Because 5 into 9 is 45. 5 and 9 are co-prime numbers. 15 and 3, can we do this? No. Even though 15 into 3 is 45, 15 and 3 are not co-prime to each other. There are many cases, like for 36, the divisibility will be 4 and 9, not 12 and 3. Okay. Why? Because product is 36 and the numbers are co-prime. 72, it will be 8 and 9. Product is 72, numbers are co-prime. So for many numbers, you will be able to find out the divisibility rule. The only two conditions are that the product of these two numbers should be equal to the larger number, or the number for which we are checking the divisibility, and these two numbers should be co-prime to each other. So this is your divisibility rule. On the basis of divisibility rule, let us try to solve these questions. You are supposed to pause the video, try to find out the solution yourself. If you get it, good. If you don't get it, you can check the solution which I am doing. Okay, now 5, 6x, 3y. Find all the number form of 5, 6x, 3y that are divisible by 36. Just now we saw divisibility of 36 is 4 and 9. So if the number is divisible by 4 and also by 9, then the number will be divisible by 36. Now what is the divisibility of 4? Last two digits should be divisible by 4. So now 3y should be divisible by 4. What is the option? 32 and 36. Yes or no? Last two digits should be 32 and 36. So 5, 6x, 32 is one of the option. 5, 6x, 3, 6 is the other option. Now the number should be divisible by 9 as well. What is the divisibility of 9? Sum of the digits should be divisible by 9. So this 5 plus 6 plus x plus 3 plus 2 should be divisible by 9. So that is 5 plus 6, 11. 11 plus 3, 14. 14 plus 2, 16 plus x by 9. Now, what is the closest multiple of 9 near 16? It is 18. So 18 by 9. So this 16 plus x should be equal to 18. So x should be equal to 2. So this number is 56232. Similarly, checking for this 5 plus 6 plus x plus 3 plus 6 should be divisible by 9. Should be divisible by 9. So which is 11, 14, 20 plus x by 9. So closest multiple of 9 about 20 is 27. by 9. So for that 20 plus x should be equal to 27. So x should be equal to 7. X should be equal to 7. So what are the two numbers? 5, 6, 2, 3, 2 and 5, 6, 7, 3, 6. 5, 6, 2, 3, 2 and 5, 6, 7, 3, 6 are the two numbers. Okay, these are the two numbers which are divisible by 36. Okay, I'm erasing this. You can check it by pausing the video. B part. Find all the number forms of 7 to xy that are divisible by 45. 7 to xy divisible by 45. For the number to be divisible by 45, it should be divisible by 5 and 9. Yes or no? We have checked this. And for number to be divisible by 45, it should be divisible by 5 and 9. Divisibility rule of 5. Last digit should be 0 or 5. Last digit 0 or 5. So the number should be of the format 7 to x0 or 7 to x5. Now divisibility rule of 9 is sum of the digits should be divisible by 9. So 7 plus 2 plus x plus 0 should be divisible by 9, which is 9 plus x should be divisible by 9. So what we can have? Either 9 by 9 or we can have 18 by 9. So when we have 9 by 9, x will be equal to 0 and the number will be 7200. But if we have 18 by 9, x will be equal to 9 and then the number will be 7290. 7290. Then 7 to x5. So that is 7 plus 2 plus x plus 5 should be divisible by 9, which is 9, 14 plus x by 9. And the closest multiple of 9 above 14 is 18 by 9. So 14 plus x should be equal to 18, which gives me x is equal to 4. So I am getting three numbers, 7245. And I am getting three numbers, 7200, 7290, and 7245. Okay. Similarly, let us try to solve C part. Find all the numbers of the form 135xy that are divisible by 45. 135xy divisible by 45. For this, the number should be divisible by 5 or 9. And for a number to be divisible by 5, last digit should be 0 or 5, as we saw in the above question. So 135x0 or 135x5. For a number to be divisible by 9, sum of the digits should be divisible by 9. So 1 plus 3 plus 5 plus x divided by 9. That is 9 plus x divided by 9. And 1 plus 3 plus 5 is how much? 9 plus x by 9. Now it can go in two directions. It can be either 9 by 9 or it can be either 18 by 9. If it is 9 by 9, x will be equal to 0. And if it is 18 by 9, x will be equal to 9. So I am getting through two numbers 13590, 13500. Now checking for this 1 plus 3 plus 5 plus x plus 5 divisible by 9. This is 9 plus 5, 14 plus x divisible by 9 can be written as 18 by 9. Yes or no? Closest multiple of 9 above 14. So 18 by 9. This gives me 14 plus x should be equal to 9, which gives me x is equal to 4. So the number I am getting is 13545. Here also I am getting three numbers 1, 2, 3. Here also I am getting three numbers 1, 2, 3. Okay. So this was our divisibility rule. Going forward with cyclicity. Cyclicity is nothing but to find out the last digit of such numbers. Now 2 raised to 165 you won't be able to calculate, right? 23 raised to 234 you won't be able to calculate, correct? But for such numbers we'll be able to find out the last digit. So first understand only unit digit, unit or last digit helps to find unit or last digit. Only unit digit or last digit helps to find the unit digit. For example, 3247 मल्टीप्लाइड बाय 239 है ना, इसका यूनिट डिजिट निकालना है. So what I'm saying, only 7 and 9 are sufficient to find out the unit digit. For example, 9 into 7 is 63. So 3 years, 6 years, and then something, something, something will come. Then for 3, we'll write 0 over here and then start the calculation. And for 2, we'll write 2 zeros over here and then start the calculation. Eventually, when we add it, I get 3. Now this 3 we have got by 7 into 9 only, that is 63. Hana? So this unit digit or this last digit, we are able to find out this last digit. We are able to find out this last digit by only these two last digits. Hana? We are able to find out the last digit by only these two last digits. So for example, what I'm saying, 17 raised to 87 का last digit is nothing but 7 raised to 87 का last digit. है ना, आगे का जो भी प्रोसेस रहेगा वो देखेंगे, है ना, because only unit digit helps me find out the unit digit of the last digit, है ना. For example, 23 raised to 234, इसका last digit will be 3 raised to 234 का last digit, है ना, because only unit digit helps me find out the unit digit. And 29 raised to 12357 is nothing but 9 raised to 12357. Okay, if we find out the last digit of this, we'll be able to find out the last digit of this, because only unit digit helps me find out the unit digit of the last digit. Moving forward, so I hope you have understood only last digit helps to find out the last digit. Moving forward, if a number ends with 0 and it has any power, the last digit will be 0. Last digit will be 0. 10 to the power or 20 to the power, anything, last digit will be 0. 1 to the power. And if the number ends with 1 and it has any power, the last digit will always be 1. Last digit will always be 1. For example, 11 square, 121, last digit 1. 11 cube, 1331, last digit 1, and so on. For any number ending with 5, you use any power, last digit will be 5 only. For example, 5 raised to 5, 5 raised to 1 is 5, 5 raised to 2 is 25, last digit 5, 5 raised to 3 is 125, last digit 5, 5 raised to 4 is 625, last digit 5. Okay. For any number ending with 6 and you have any power, last digit will be 6 only. Last digit will be 6 only. For example, 6 raised to 1, last digit 6. 6 raised to 2, 36, last digit 6. 6 raised to 3, 216, last digit 6. 6 raised to 4, जो कुछ भी होता होगा लास्ट डिजिट इसमें भी 6 ही आएगा. 1296 होता है तो लास्ट डिजिट इसमें भी 6 ही आएगा, है ना. So remember this thing. If a number is ending with 0 or 1 or 5 or 6, then their last digits are 0, 1, 5 or 6 respectively. पहले इतना लिखो, फिर आगे की स्टेप पे जाते हैं. ठीक है. Next, if the number is ending with 2, so 2 raised to 1, last digit is 2. 2 raised to 2, last digit is 4. 2 raised to 3, last digit is 8. 2 raised to 4 is 16. Last digit is 6. 2 raised to 5 is 32. Last digit is 2. And 2 raised to 6 is 64. Last digit is 4. And if you observe 2, 4, 6, 8, again it will be 2, 4, 6, 8. And there is a cycle of 4. And there is a cycle of 4. 2 raised to 7 is 128. Last digit is 8. And 2, 4, 8. के बाद 2 raised to 8 is 256. Last digit is 6. है ना. Now 2 raised to 9 is 512. Last digit is 2. है ना. Again this cycle will repeat. So what do we see? Cyclicity of 2 is 4. Cyclicity of 2 is 4. This is what we can conclude over here. Cyclicity of 2 is 4. Now let us say, if there is a question 2 raised to 46, what will be the last digit? 2 raised to 46, what will be the last digit? I'll tell you the lengthier method first, and then I'll tell you the shortcut. So 2 raised to 4, last digit 6. 2 raised to 8, again last digit 6. 2 raised to 12, again last digit 6. 2 raised to 20, last digit 6. And all the multiples of 4 will have last digit 6. 2 raised to 32, last digit 6. 2 raised to 40, last digit 6. And all the multiples of 4. 2 raised to 44, last digit 6. 2 raised to 45, it is a cycle. After 6, this will come, 2 will come. So last digit will be 2. 2 raised to 46, last digit will be 4. Last digit will be 4. This is the lengthier method. But then this is possible because I had 2 raised to 46 only. I could calculate. What if the numbers are this big? And इतने बड़े अगर numbers आए तो what will we do? We do 46 divided by 4. Why 4? Because cyclicity of 2 is 4. What is the remainder? Remainder is 2. And 46 divided by 4. Remainder is 2. So 2 raised to 46 will have the same remainder as 2 raised to 2. 2 raised to 46 will have the same remainder as 2 raised to 2, which is 4. Will have the same last digit as 2 raised to 2, which is 4. ठीक है ना? Which is 4. ठीक है ना? For example, 2 raised to 197. What is the last digit? What do we do? 197 divided by 4. Why 4? Because cyclicity of 2 is 4. What is the remainder? Remainder is 1. So 2 raised to 97 will have the same remainder as 2 raised to 1. What is the last digit of 2 raised to 1? 2. So 2 raised to 197 will also have the same digit as 2 raised to 197 will also have last digit as 2 because it is the last digit of 2 raised to 1. है ना? 2 raised to 2 raised to 291. What is the last digit? What do we do? 291 divided by 4. What is the remainder? Remainder is 3. So 2 raised to 3. Whatever is the last digit of 2 raised to 3 will be the last digit of 2 raised to 291, which is 2 raised to 3 last digit is 8. 2 raised to 3 last digit is 8. Okay, 2 raised to 3 last digit is 8. This is how you can find out the last digit. Now let us say cyclicity of 3. So 3 raised to 1 last digit 3. 3 raised to 2 9 last digit 9. 3 raised to 3 27 last digit 7. 3 raised to 4 81 last digit 1. है ना? 1 के बाद फिर से रिपीट हो ही जाएगा. 3 raised to 5 is 243 last digit 3. 3 raised to 6 is 729 last digit 9. So here 3971 will be the cyclicity. So cyclicity of 3 is also 4. So if there is a number 33 to the power 82, 33 to the power 82, we want to find out the last digit. It is nothing but to find out the power of last digit of 3 to the power 82 because only unit digit will help you find out the unit digit. So 33 to the power 82 is nothing but 3 to the power 82 to find out the last digit. Now 3 to the power 82, what do we do? 82 divided by 4. Cyclicity of 3 is 4. Cyclicity of 3 is 4. So as soon as we get the cyclicity of 3 as 4, we do 82 by 4. Remainder is 2. So this thing will also have the remainder. Last digit of 3 raised to 2 will be same as last digit of 3 raised to 82, which will be same as last digit of 33 raised to 80, which is nothing but 9. So 33 raised to 82, last digit will be 9. Then 4 की cyclicity, 4 raised to 1 is 4. 4 raised to 2 is 6. 4 raised to 3 is 64. 4 raised to 2 is 16, no. So unit digit 6. 4 raised to 3 is 64, unit digit 4. 4 raised to 4 is 256, unit digit 6. So what we have? 4646, cyclicity of 4 is 2. Cyclicity of 4 is 2. ठीक है ना. For example, 124 to the power 283. Find out the last digit of this. It is nothing but 4 to the power 283 का last digit है ना, because unit digit, only unit digit helps me find out the unit digit. Then what do we do? 283 divided by 2. Remainder is 1. So 4 to the power 1, whatever is the last digit, that is going to be the last digit of this as well, 124 to the power 280. ठीक है. Next, what we are left with, 6 is done. 7, 8, and 9 is left. Write down everything. Then we'll look at the cyclicity of 7, 8, and 9. Okay. Moving forward. 7 raised to 1 is 7. 7 raised to 2 is 49. So 9. 7 raised to 3 is 343. So 3. 7 raised to 4 is 2401, which is 1. 7 raised to 5. As soon as 1 comes, it will repeat. Again 1. Again 7. So cyclicity of 7 is 4. Cyclicity of 7 is 4. 8. 8 raised to 1 is 8. 8 raised to 2 is 64. So unit digit 4. 8 raised to 3 is 1. 8 raised to 3 is 512. Unit digit 2. 8 raised to 4 is 4096. Unit digit 6. 8 raised to 5 will be 6 into 8, 48. So again, cyclicity of 8 is of 4. And then cyclicity of 9. 9 raised to 1 is 9. 9 raised to 2 is 81. Unit digit 1. If it is 1, it will repeat again. 9 raised to 3 is 729. Unit digit 9. So cyclicity of 9 is 2. Okay, write this down. Then we'll apply it on the questions. ठीक है. So 2 raised to 165. 2 raised to 165. What we'll do? 165 divided by 4. Why? Because cyclicity of 2 is 4, which will give me the remainder of 1. So 2 raised to 65, 165 will have the same remainder as 2 raised to 1, which is 2. Last digit of this will be 2. 17 raised to 87 will have the same last digit as 7 raised to 87, which will have the cyclicity of 7 is 4. No? We have just checked cyclicity of 7 is 4. So remainder is 3. So last digit of 7 raised to 3. Last digit of 7 raised to 3 is 343. So 3. Unit digit will be 3. Very easy. 23 raised to 234, which is 3 raised to 234. Which is 3 raised to 234. Now 234 divided by 4. And why? Because cyclicity of 3 is also 4. So we get remainder as how much? 232 तक गया. Remainder will be 2. So 3 raised to 2 will be the remainder. Whatever be the unit digit of 3 raised to 2 will be the unit digit of 3 raised to 234, which will be the unit digit of 23 raised to 234. So it is 9. And the last digit is 9. And then 29 raised to 1, 2, 3, 5, 7 will have the same last digit as 9 raised to 1, 2, 3, 5, 7. Now 1, 2, 3, 5, 7 divided by 2. Why? Because cyclicity of 9 is 2. And a cyclicity of 9 is 2. We get the remainder as 1. So this thing will have the remainder as 9 raised to 1, which is 9. So unit digit for 29 raised to 1, 2, 3, 5, 7 is 9 only. Okay. These were easy questions. Moving forward here, 47 raised to 74 plus 74 raised to 47. So 7 raised to 74 will have the same unit digit. 7 raised to 74, that is 74 by 4. Na? Because cyclicity of 7 is 4. Unit digit will be remainder will be 2. So 7 raised to 2, which will leave the remainder which will leave the last digit as 9. If we do this, 4 raised to 47, which is 47 divided by 2, because cyclicity of 4 is of 2. So remainder is equal to 1. So 4 raised to 1, which is 4. So 9 plus 4, 13 will be the last digit. So 13, 2 digits cannot be the last digit. So only 3 will be the last digit. And only 3 will be the last digit. Now, further questions are very easy. What we have 1, 2, 3 to the power 225 into 625 to the power 125 into 29 to the power 111. Last digit here will be 5 because 5 raised to anything. 5 raised to anything. Last digit is always 5. Now, 5 is multiplied by an odd value. This is an odd value. 5 is again multiplied by an odd value. So when 5 is multiplied by an odd value, last digit is 5 only. When 5 is multiplied by an odd value, last digit is 5 only. When 5 is multiplied by an even value, last digit is when 5 is multiplied by an even value, last digit is 0. Yes or no? This is how you can do it. Okay. So here the last digit is going to be 5. Next, here the last digit is going to be 5. Here the last digit is going to be even. Because 2 to the power anything is going to give me even last digit. So 5 into even value, last digit is 0. 5 into even value, last digit is 0. 6 raised to anything, last digit is 6. 6 raised to anything, last digit is 6. 4 raised to 169. 4 raised to 169. So 169 divided by 2. Remainder is 1. So this is going to give me 4 raised to 1 as the remainder. So 4. Okay. So this is how much? 24 plus 0. Last digit is going to be 4 only. Last digit is going to be 4 only. Okay. Last digit is going to be 4 only. Okay. Now moving forward to the concept of remainder. So concept of remainder. What do we have over here? Let us say 10 when divided by 8 leaves a remainder of 2. 11 when divided by 8 will leave the remainder of 3. Now when 10 into 11 is divided by 8, the remainder will be 2 into 3. As soon as the numbers are multiplied, the remainders are also multiplied. As soon as the numbers are multiplied, the remainders are also multiplied. So the remainder will be 6. You can check. This is 110 divided by 8. So 110 divided by 8. 1s are 8, 30, 3s are 24, remainder 6. I hope you have understood. As soon as the numbers are multiplied, the remainders are also multiplied. So 15 into 14 into 13 divided by 12. What will be the remainder? Here the remainder will be 3. Here the remainder will be 2. Here the remainder will be 1. Overall remainder will be 6. Here as well. Overall remainder will be 6. You don't have to multiply. You don't have to multiply 15 into 14 into 13. And you can directly write this down. Remainder for 15 is 3. Remainder for 14 is 2. Remainder for 13 is 1. ठीक है, this is how you can write it. ठीक है. So on the basis of that, let us try to solve these questions. The remainder when each of the following is divided by 8. ठीक है. So पूरा लिख दो उसके नीचे. What we have 17 into 23 into 126 into 38 divided by 8. So now 17 divided by 8, remainder 1. 23 divided by 8, remainder 7. 126 divided by 8, remainder 6. 38 divided by 8. 38 divided by 8, remainder again 6. What we have? 7 into 6 is 42 divided by. So now 1 divided by 8, तो वो तो वैसे का वैसे ही जाएगा. 42 divided by 8, remainder 2. 6 divided by 8, remainder 6. Now 2 into 6 is 12 divided by 8, remainder is 4. This is the method by which we can calculate the remainder. Now, once you get 7 into 6 into 6, don't try to multiply 7 into 6 into 6 into a bigger number and then try to calculate the remainder. Don't do that. Multiply just two numbers, 7 into 6, that is 42. For 42, you will get the remainder as 2. For 6, we will get the remainder as 6. Just multiply 2 and 6, 12. So play with smaller numbers. That is what I'm trying to say. Next is 243 into 245 into 247 into 249 into 251 divided by 12. So now 243 divided by 12, remainder 3. 245 divided by 12, remainder 5. 247 divided by 12, remainder 7. है ना? अभी I am expecting कि इतना basic आएगा आपको. 240 is properly divisible. So plus 3 plus 5 plus 7, that is what we have. Then 249 divided by 12, remainder 9. 251 divided by 12, remainder 11. Now this will be the value. 3 into 5 is 15. 7 into 9 is 63 into 11 divided by 12. So 15 divided by 12, remainder 3. 63 divided by 12, remainder 3 into 11 divided by 12. So this is 9 into 11. 99 by 12. Remainder will be 3 overall. Overall remainder will be 3. We need to understand one thing. The remainder should always be less than the divisor. Okay. So once you are dividing any number by 12, the remainder should be less than 12. Okay. Third C part. 1021 into 2021 into 3021 divided by 40. 1021. So 98, 31. Remainder 3. 202, 196, 51. 196, 51. Remainder 9. 394, 81. Remainder 11 divided by 40. So 9 into 11, 99. 99 into, so 3 into 99 by 40. So that is 3 into 14, 84, 98. Remainder will be 1 divided. So 3 into 1 by 14. So remainder will be 3. Okay. Now let us try to understand the concept of negative remainders and then try to apply it on the questions. So negative remainder, what do we understand by that? When 15 is divided by 8, we get the remainder as 7. Why? Because 15 divided by 8, 1s are 7, 1s are 8, remainder 7. But if I do something like this, 15 divided by 8, 2s are 16, and then the value will become minus 1. 2s are 16, and then the value will become minus 1. Okay? So I can say that 15 when divided by 8 can give me negative remainder of minus 1. It can give me a negative remainder of minus 1. ठीक है ना? ये negative remainder का concept समझो. For example, 22 divided by 12. Generally, we will say that the remainder is of 10. But when 22 is divided by 12, we can use this as minus 2. Now, working with 10 is difficult and working with 2 is easy. Or working with larger number is difficult and working with smaller number is easy. That is why we are getting into this concept of negative remainder. Let me give you an example of negative remainder. So 243 into 245 into 247 into 249 into 251. And we have solved this question using regular remainder method. Now using negative remainder. So 243 divided by 12, remainder 3. 245 divided by 12, remainder 5. 247 divided by 12, remainder 7. 249 divided by 12, remainder minus 3. We would have taken remainder as 9. Generally, we would have taken remainder as 9. But we are taking remainder as minus 3 because working with 9 is obviously difficult. Multiplying any number with 9 is obviously difficult than multiplying any number with 3. Okay, you may not realize the importance here, but this is the concept. Once we apply it on the higher level questions, you will understand that using negative remainder actually eases out the calculation. So 251 divided by 12. We would have, in regular remainder method, we would have written remainder as 11, but here I am writing -1, है ना? Divided by 12. Now we have smaller numbers to work with. So 3 into 5, 15. This minus minus will get plus. Will become plus. 7 into 3, 21. So 15 divided by 12, remainder 3. 21 divided by 12, remainder -3. Overall, if you see, remainder is -9. But in practical life, can the remainder be -9? No. If I ask you any number divided by any other number, will you give me the remainder as negative? No, you will always give me the remainder as a positive value. Yes or no? This is the negative remainder concept, or this is the some we are making some changes to ease out our calculation. This is what we are doing here. But actually, the remainder should be positive only. Now, once we have the remainder as -9, how to get that positive remainder? It will be 12. This 12, the divisor, -9. So remainder would be 3. So the remainder would be 3. Okay? This is all you need to do. Okay, the remainder would be 3. And in our regular method also, we got the remainder here as 3. Okay? Moving forward, binomial expansion. Binomial expansion. So what is binomial expansion? A plus b to the power n. How do we write it? It is nc0. A to the power n, b to the power 0. The nc1, a to the power n minus 1, b to the power 1. The nc2, a to the power n minus 2, b to the power 2, up to nc n minus 1, a to the power 1, b to the power n minus 1, and then nc n minus 2, a to the power 0, b to the power n. Okay, so this is your binomial expansion. Try to understand what is there. We are going to use a very small part of it for our remainder theorem, but try to understand what is there. So you have nc0, nc1, nc2 up to ncn. So nc0, nc1, nc2 up to ncn, it is increasing. Then look at the power of a. Power of a is reducing. A to the power n minus 1, a to the power n, a to the power n, a to the power n minus 1, a to the power n minus 2, up to a to the power 1, a to the power 0. The power of a is reducing. And the power of b is increasing. B to the power 0, b to the power 1, b to the power 2, b to the power n minus 1, b to the power n plus 1. n. So the power of n is increasing. What are the total number of terms? Total number of terms are n plus 1. We are going to look at this again in permutation and combination. But number of terms in a plus b to the power n are always n plus 1. Now, where do we use it? We are using it to find out a plus b whole square, which is 2c0, a to the power 2, b to the power 0. Then 2c1, a to the power 2 minus 1, that is 1, and b to the power 1. And 2c2, a to the power 0, b to the power 2. Now 2c0 is 1, a to the power 2, b to the power 0 is 1. 2c1 is 2, a to the power 1 is a, b. This is 1, this is 1, this is b square. So this is what? A plus b whole square. A square plus 2ab plus b square. Similarly, a plus b to the power 3 is calculated using this formula. A plus b to the power 4 can be calculated using this formula. A plus b to the power 10 can also be calculated using this formula. This is your binomial expansion. Once you understand the binomial expansion, let us try to understand the remainder. What does remainder theorem say? A plus b to the power n when divided by a leaves the remainder of b to the power n. a plus b to the power n when divided by a leaves the remainder of b to the power n. Okay. Now understand how will this happen. A plus b to the power n will be written as nc0 a to the power n b to the power 0, nc1 a to the power n minus 1 b to the power 1, nc2 a to the power n minus 2 b to the power 2 up to nc n minus 1 a to the power 1 b to the power n minus 1 and ncn a to the power 0 b to the power n. Now, when this term is divided by a, each and every term of binomial expansion will be divided by a. Each and every term will be divided by a. है? Now, what do you see? You see a multiple of a over here. है? A raised to n is multiple of a. So this term will leave a remainder of 0. And here also you see a multiple of a. So this term will also leave a remainder of 0. This term will also leave a remainder of 0 because you see multiple of a. Okay. Here also you have a and this is a. So this numerator will be divisible by this denominator a. So this term will also leave a remainder of 0. Only this term will leave some remainder because we don't have a to power anything. Because a to power 0 is 1. NCN is also 1. So this term will leave a remainder of p to power. This term will leave a remainder of p to power. So this is the concept. This is the reason behind the concept. Now we don't have to apply the concept or use the following steps to find out the answer. We will do it directly. We know that 9 to the power 20 divided by 8. What will be the remainder? If they ask me, 9 to the power 20 divided by 8. What will be the remainder? So I can write it like this: 8 plus 1 to the power 20 divided by 8. So this is your A, this is your A, this is your B. Correct. What is the remainder in such cases? B to the power n. No? So 1 to the power 20 will be the remainder. Now 1 to the power 20 is nothing but 1. Remainder is nothing but 1. And try to understand this. This 9 can be written as 8 plus 1. Okay. Now the remainder theorem is something like this. We can also use multiple of A. Multiple of A. For example, 21 to the power 43 divided by 10. What will be the remainder? Now, can I write it like this? 20 plus 1 to the power 43 divided by 10. Can we write it like this? Yes, we can. Now, each and every term will have 20 in it. Total there will be 44 terms. As it is raised to 43. Total there will be 44 terms. So out of those 44 terms, each and every term, out of those 44 terms, 43 terms. So like this, 20 raised to 43, 20 raised to 42, 20 raised to 41, up to 20 raised to 1, and 20 raised to 0. So all these terms are divisible by 10 because 20 is divisible by 10. So all the powers of 20 will also be divisible by 10. Okay, so here also we will get the remainder as 1. Why? 1 to the power 43. Why? Because this is A ka multiple. This is A and this is B. Remainder is still B to the power n, which will give me the remainder as 1. Correct. So this is your basic remainder theorem. Then we'll solve few questions on remainder theorem. Followed by we'll solve few questions on Fermat theorem and then Wilson theorem. Okay. So try these questions. Another important point, we'll come back to this. And try to solve these questions. You are supposed to pause the video and then continue. I'll continue right from here. Find the remainder when these are divided by 34. So 74 plus 75 plus 78 plus 57 plus 197 is divided by 34. Simple side. 73 we have. So 73, remainder will be 5. Here remainder will be 7 plus. Here remainder will be 60, 10. Here remainder will be minus 11. है ना? So 57 divided by 34, ones are 34, remainder is 23. But if I do twos are, so it will become 68 and remainder will be minus 11. है ना? And then 34, 170. Here the remainder will be minus 7. So minus minus will get cancelled. This is 15 minus 11. Remainder will be 4. As simple as that. Next, find the remainder when it is multiplied. So 73 when divided by 34, 5 का remainder, 75 divided by 34, 7 का remainder, 78 divided by 34, 10 का remainder, 8, 57 divided by 34, minus 11's remainder, and then minus 7's remainder. Minus minus will get plus. All of this has to be divided by 34. So this is 35, which will leave a remainder of 1. This is 70. 70 divided by 34 will leave a remainder of 2, and this is 11. So this is 22 by 34. It will leave a remainder of 22. Now if 37 is also added over here, so with 37 the remainder will be 3. So it will be multiplied by 3. This thing will be multiplied by 3. This will be multiplied by 3. So it is 66 divided by 34. Remainder will be 32. And remainder will be minus 2, which is 32. Okay. Now, 43 raised to 197 divided by 7. What will be the remainder? And this is what we are going to look through remainder there. So, 43. What is the closest multiple of 7 near 43? It is 42. So 43 to the power 197 can be written as 42 plus 1 to the power 197 divided by 7. Now all the terms having 42 will leave a remainder of 0 when divided by 7. All the terms having 42 will leave the remainder of 0 when divided by 7. So this will leave a remainder of 1 to the power 197, which is nothing but remainder of 1. Next is 51 to the power 203 divided by 7. Now, closest multiple of 51 near closest multiple of 51, closest multiple of 7 near 51 is 49. And 49 to the power 20, 49 plus 2 to the power 203 divided by 7. All the terms having 49 will leave a remainder of 0. So my eventual remainder will be 2 to the power 203 divided by 7. But here we cannot stop. The remainder should be less than 7. No? So 2 to the power 203 will be much higher than 7. So we'll have to work on this as well. Now, which is the 2's power which is closest to 7? So 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. 8 is a good number because I can write it as 7 plus 1 raised to n divided by 7. So 8 is a good number. So I want 2 cube. I want 8, and 8 for 8 I need 2 cube. So I have 2 cube. So what do I do? 203 divided by 3. What do I get? 6 is 18, 23. 7 is 21, remainder 2. So I have 2 to the power 3 can be taken 67 times. 2 to the power 3 can be taken 67 times. And it can then be multiplied by 2 square. Overall, if you see, it will be equal to 203. This is an important step. You should be able to do. The power here and the overall power here. So 3 into 67 is 201. 201 plus 2. Now what is this? 2 raised to 201. 3 into 67. Into 2 raised to 2 is 2 raised to 203. I hope you understand this. Why? Because a raised to m into a raised to n is a raised to m plus n divided by 7. So what we have? 8 to the power 67 into 2 square is 4 divided by 7. 8 can be written as 7 plus 1 to the power 67 into 4 divided by 7. Now 7 divided by 7, all the terms having 7 will leave the remainder of 0. Only 1 to the power 67 will be the remainder into 4 divided by 7, which is nothing but 1 into 4. The overall remainder is 4. Overall remainder is 4. Okay. Next thing is, so what we understand, 2 to the power 3 is very much beneficial for 2 to the power 3 is very much beneficial for. So 59 to the power 28 can be written as 63 minus 4 to the power 28 divided by 7. है ना? So using the concept of negative remainders now. है ना? How will it help me? Let us see it. 63 minus 4 to the power 28 will divided by 7 will leave a remainder of minus 4 to the power 28. है ना? Try to understand this. 63 by 7, all the terms having 63 will leave the remainder of 0 because 63 is divisible by 7. Now, which is nothing but 4 to the power 28 divided by 7 because minus 4 to the power 28 is equal to 4 to the power 28. Then I know that 2 to the power 3 is very much beneficial for me. So I try to convert it here. So 2 square, 4 is 2 square to the power 28 divided by 7. So 2 to the power 56. 2 into 28 is 56, no? Divided by 7. Divided by 7. Now, I know that 2 cube is pretty much beneficial for me. What do I do? 56, 3. And I want 2 cube. Then how many times 2 cube I can take? I'll get this from here. So 18s are 54. Remainder is 2. So this is 2 cube to the power 18 into 2 square. This remainder is 2 square divided by 7. So what we have 8 to the power 18 into 4 divided by 7. This 8 can be written as 7 plus 1 to the power 18 into 4 divided by 7, which will leave a remainder of 1 to the power 18 into 4, which is nothing but remainder of 4 only. Which is nothing but remainder of 4 only. Okay? So it is beneficial for us. Next thing that is beneficial is, for that we will have to solve the next question. 67 to the power 99 can be written as 63 plus 4 to the power 99 divided by 7, which will leave a remainder of 4 to the power 99 divided by 7, which is nothing but 2 square to the power 99 divided by 7, which is nothing but 2 to the power 198 divided by 7, which is nothing but 2 cube is beneficial for me because 2 cube is 8. 8 can be written as 7 plus 1 to the power anything divided by 7. So 2 cube to the power 66 divided by 7. If you can observe, 3 into 66 is 198. No remainder, so directly we'll write like this. Okay. So, which is 8 to the power 66 divided by 7 can be written as 7 plus 1 to the power 66 divided by 7 will leave a remainder of 1 to the power 66. That is nothing but the remainder of 1. Next is 75 to the power 80 divided by 7 can be written as 77 minus 2 to the power 80 divided by 7. 77 minus 2 to the power 80 divided by 7. Yes or no? Which will leave a remainder of minus 2 to the power 80. Because 77 is multiple of 7 and all the terms having 77 will be divisible by 7, so leaving a remainder of 0. Only the last term, which is minus 2 to the power 80, will leave some remainder, which is minus 2 to the power 80, which is nothing but 2 to the power 80 divided by 7. I know that 2 cube is beneficial for me. So 80 divided by 3. 1 are 80, 2 are 6, 20, 6 are 18, remainder 2. So 2 to the power 26, and then 2 remainder is remaining. So 2 to the power 2 divided by 7. So this is 8 to the power 26 into 4 divided by 7, which can be written as 7 plus 1 to the power 26 into 4 divided by 7, which is nothing but 1 to the power 26 into 4 divided by 7 will leave with a final remainder of 4. And then the next one is very easy. 41 to the power 77 can be written as 42 minus 1 to the power 77 can be written divided by 7 divided by 7. We leave a remainder of minus 1 to the power 77, which is nothing but the remainder of minus 1, which is nothing but the remainder would be actually 7 minus 1, which is the remainder is of 6. Okay, the remainder is actually of 6. Next thing, find the remainder when divided by 70. So 21 raised to 875 when divided by 17, what will be the remainder? Simply write it like this: 17 plus 4 to the power 875 divided by 17. So it will leave a remainder of 4 to the power 875 divided by 17. Now 4's which multiple is closer to 70? So 4 to the power 1 is 4. 4 to the power 2 is 16, which can be written as 17 minus 1, you know, to the power something divided by 17. So 16 is a suitable or a favorable value for us. For that, 4 square is favorable for us. So what we have 4 square. Now 4 square कैसे लिखेंगे? 875 है ना, 2 जा, so that is 437 जा 874 and remainder 1. So this is 437 times into 4 to the power 1 divided by 7. So what we have 16 to the power 437 into 4 divided by 7, which is nothing but 17 minus 1 to the power 437 into 4 divided by 7, which is nothing but minus 1 to the power 437 into 4 divided by 7, which is nothing but minus 1 into 4 by 7, which is nothing but the remainder is of minus 1. But negative remainder is not possible, so remainder will be 17 minus 4. That is the remainder is 30. Remainder is 30. ठीक है. Next, what we have 54 to the power 124. So 54 to the power 124 can be written as 51 plus 3 to the power 124. 51 plus 3 to the power 124. Okay, which will leave a remainder of 3 to the power 124 when divided by 17, obviously. Now 3 to the power 124 divided by 17. How do we do that? 3 raised to 1 is 3. Is it closer to 17? No. 3 raised to 2 is 9. 3 raised to 3 is 27. 3 raised to 4. 3 raised to 4 is 81. 243. 243 कितना जाएगा? 170. 170 plus 85 is 255. 255. And we have 243. No. So this 81 is closer to 85 minus 4. 85 minus 4. है ना? 85 is divisible by 70. So 81 is a beneficial value or a suitable value. So 3 to the power 4 is suitable for me. So how do I write it? 3 to the power 4 whole to the power 31. No? So because 4 into 31 is 124 divided by 7, which is nothing but 81 to the power 31 divided by 7 can be written as 85 minus 4 to the power 31 divided by 7, which is nothing but minus 4 to the power 31 divided by 7, which is nothing but 4 to the power 30 into minus 4 divided by 7. Now 4 square is beneficial for me. 4 square is 16, which is 70 minus 1. So what I'll do? 4 square to the power 15 into minus 4 divided by 7, which is 60, which is 70 minus 1 to the power 15 into minus 4 divided by 17. We are dividing by 17 here. Dividing by 17. So this will leave a remainder of minus 1 to the power 15 into minus 4, which is nothing but minus 1 into minus 4, which will leave a remainder of 4 only. Which will leave a remainder of 4 only. Okay. Next is C option is very easy. Let us try to do it. C, question C is very easy. 83 to the power 261 divided by 17 can be written as 85 minus 2 to the power 261 divided by 17. Which will leave a remainder of minus 2 to the power 261 divided by 17, which is nothing but 2 to the power 260 into minus 2 divided by 17. I know that 2 to the power 4 is 16, right? 2 to the power 4 is 16, which can be written as 17 minus 1. So 2 to the power 4 whole to the power 65, because 4 into 65 is how much? 260 into minus 2 divided by 16 can be written as 17. 16 to the power 65 into minus 2 divided by 17 can be written as 17 minus 1 to the power 65 into minus 2 divided by 17 can be written as minus 1 to the power 65 into minus 2 divided by, because this will be the remainder of minus 1 to the power 65, which is nothing but minus 1 into minus 2 का remainder, which is nothing but remainder of positive 2, minus minus plus, so remainder will be positive. ठीक है, remainder will be positive. Moving forward to D part, 25 raised to 102 can be written as 17 plus 8 to the power 102. 17 plus 8 to the power 102 divided by 17, which will leave a remainder of 8 to the power 102 divided by 17. Now this is 8 is 2's cube and 2 to the power 4 is 16. So let us try to convert it into 2's power. So this is 2's cube to the power 102 divided by 17, which is 2 to the power 306 divided by 17, which is 2 to the power 4. 2 to the power 4. So just do this. 306 divided by 4. So this is 76. 304. Remainder 2. So 2 to the power 4 whole to the power 76 into 2 to the power 2 divided by 17 can be written as 16 to the power 76 into 4, 2 square is 4 by 17, which can be written as 17 minus 1 to the power 76 into 4 by 17, which will leave a remainder of minus 1 to the power 76 into 4 by 17, which is nothing but minus 1 to the power 76 is 1 into 4 by 17, which will leave a remainder of 4 only. This will leave a remainder of 4 only. Okay. So this was a basic remainder theorem. Now, application of remainder theorem we have to see. Before the application of remainder theorem, let us try to understand another important point which we had skipped earlier. Now, another important point. Now, tell me, when 100 is divided by 24, 100 is divided by 24, the remainder is 1. Remainder is 4 in fact. But then this thing can be reduced. 100 divided by 24. So when divided by 4, it will be 6. When divided by 4, it will be 25. Now 25 divided by 6. 25 divided by 6. Remainder will be 1 only. Now that these values are divided by 4, my remainder is also divided by 4. Now that these values are divided by 4, these values are also divided. The remainder is also divided by 4. And we have to take into consideration that whenever we reduce by any value, let us say 26 divided by 12, we know that remainder is of 2. But when I reduce it, so to 13 and 6, so what I'm doing? Dividing by 2. So what I'm getting? 13 by 6. I'm getting remainder as 1. So my remainder is also be or has also got divided by 2. So whenever I do this and I get the remainder, whenever I do this and I get the remainder, I just have to make sure to get the final remainder. I'll have to just multiply it with 2. To get the final remainder, I'll have to just multiply it by 4. Because I have divided by 4, I'll have to multiply by 4 to get the final remainder. Okay. So this is what we are going to get to do in the application of remainder theorem. So application of remainder theorem, directly try to solve this question. Okay, directly try to solve this question. Okay, directly try to solve this question. Okay, you will understand the application. So remainder theorem, remainder theorem can be used to find out last digit, last 2 digits, last 3 digits and all. And last 3 digits and all. Okay. How? If there is a number divided, if there is a number n, if I divide it by 10, what I will get? Remainder, which is the unit digit. Remainder, which is the unit digit or last digit. For example, 3, 4, 2, 8, 9, 2, 3, 6. Now when divided by 10, it will leave a remainder of 6, which is the last digit. If they ask me to find out the last 2 digits, I just divide the number by 100. It will give me the remainder, which is last 2 digits. Let us say if I divide this number by 100, I'll get the last 2 digits. If I want to find out the last 3 digits, I'll just divide it by 1000, which will leave a remainder, which are nothing but last 3 digits, which are nothing but last 3 digits. If I divide this number by 1000, this is the last 3 digits which will get. There is the last 3 digits which will get. Correct? So this is how we are going to apply the remainder theorem. And we are also going to use that important one. So they are asking us to find out the last 2 digits of this. 21 into 7 into 14 into 37 into 49. How do we find out the last 2 digits? We divide the number by 100. So we divide it by 100. Now, what I am doing? I am reducing it. So this is 7. This is 50. What I have done? I have divided by 2. Remember this. Whatever final remainder I get, I'll have to multiply it by 2. Okay, I'll have to multiply it by 2. So 21 into 7 is 49 into 37 into 49 divided by 50. So remainder 21, here remainder minus 1. And 49 divided by 50, remainder minus 1. 37 divided by 50, remainder minus 13. And 49 divided by 50, remainder minus 1. So ये minus minus plus हो गया divided by 50. Now 21 into 13. This is 13, this is 26. So this is 3, this is 7, this is 2. So minus 273 divided by 50 will leave a remainder of minus 23. It will leave a remainder of minus 23. But remainder cannot be minus 23. No? So it will be actually 50 minus 23. 50 minus 23, the remainder is 27. But this is the remainder when we have divided it by 50. Remember, we divided or we reduced the term by 2. So now to get the final answer, we'll have to multiply this remainder by 2. So remainder will be 27 into 2, that is 54. So last 2 digits will be 54. Simple cheez hai. If we divide, if we reduce this, now what I have done, I have solved this question. I have solved this question and found out the remainder for 50. If I want to find out the remainder for 100, I just have to multiply it by 2. Okay. Next is last 3 digits of 123 into 4 into 18 into 139 into 107 divided by 1000. To find out the last 3 digits, I'll have to multiply it by, I'll have to divide it by 1000. Whatever is the remainder will be the last 3 digits. Now this is 4 से divide here to 250. So remember, I have divided by 4. Then 18 से divide किया तो 9 आ जाएगा, यहाँ पे 125. तो remember I have divided by 2. So 1 by 4 into 1 by 2 कर दिया मैंने. That is 1 by 8. I have already divided by 8. Eventually my final answer, final remainder, I'll have to multiply it by 8. So what I have now, 123 into this 9 into 139 into 117 divided by 125. So 123 divided by 125 minus 2 is the remainder. 9 divided by 125, 9 is the remainder. 139 divided by 125, 14 is the remainder. 117 divided by 125 minus 8 will be the remainder. Minus minus plus हो गया. So this is how much? 72. Yes or no? This is 72. 72. 9 8 is 72. 72 into 2 is 144 into 14 divided by 125. So 144 will leave a remainder of 19 into 14 divided by 125. Now 19 into 14. 19 into 14. 14 nines are 126. 12 carry. 14 ones are 14 plus 12. 14 plus 12 is 26. So 266 divided by 125. The remainder here is of 16. But if you remember, we had divided the remainder by, or we had reduced it by 8. Now we'll have to multiply 8 by 8 to get the actual remainder. So actual remainder will be 16 into 8, that is 128. Actual remainder will be 128. So last 3 digits will also be 120. Sir, last 3 digits will also be 128. Okay. Now Fermat's theorem. For this type of expression, a to the power p minus 1 divided by p will always leave a remainder of 1. And it will always leave a remainder of. So what is the statement for Fermat's theorem? For any prime number p, the remainder of the expression, remainder of the expression, this remainder of the expression a to the power p minus 1 when divided by p is 1, provided a is not the multiple of p. A is not the multiple. So this is what Fermat's theorem says. And Fermat's theorem says that, let us say with example, if I have to tell 17 is a prime number, let us say 24. 24 is not divisible by 17 and it is not a multiple. And then if this is p, this is p minus 1. So this must be 17 minus 1, 16. In such cases, we'll get the remainder as well. Now, this Fermat's theorem is actually based on your regular remainder theorem. But then this Mr. Fermat has taken the effort and given us this formula. And now we'll be using directly his formula. Okay, for example, one more example I'll give you. Let us say 23 to the power 82 when divided by 83. So p is the prime number. 23 is not divisible by 83, obviously. And this is p minus 1. In such cases, the remainder will be 1. Okay, this is your Fermat's theorem. So what will be the remainder when 127 to the power 133 is divided by 67? 127 to the power 133 is divided by 67. So we cannot directly apply the Fermat's theorem. We know that 127 is not divisible by 67. So this is p, this is your a, and here we should have p minus 1, which is 66. So if we have p minus 1, which is 66, we will be getting the remainder as 1. So let us try to convert it in that format. So 127 to the power 66 into 127 to the power 66. 66 plus 66 is 132 into 127 to the power 1 when divided by 67. So this term will leave a remainder of 1 according to Fermat theorem. This term will also leave a remainder of 1 according to Fermat theorem, and 127 divided by 67. 127 divided by 67 will leave a remainder of 60. This thing will leave a remainder of 60. ठीक है. Next, find the remainder when 43 to the power 91 is divided by 90. So 43 is there, 19 is there. This is your P, this is your A. A is not divisible by P. I want P minus 1, that is 18 over here. This thing will leave a remainder of 1. But what I have, 43 to the power 91 into when divided by 90. So can I write it like this, 43 to the power 18. 43 to the power 18. It will become 43 to the power 36. Then 43 to the power 18. 43 to the power 18. 43 to the power 18 into 43 to the power 1 divided by 90. Divided by 90. Now this term will leave a remainder of 1. This term will leave a remainder of 1. According to Fermat's theorem, this term will leave a remainder of 1, 1, 1, and 43 divided by 19 will leave a remainder of 5. So overall remainder will be of 5. Overall remainder will be of 5. Okay. Moving forward to Wilson's theorem. This is the last theorem. Wilson's theorem states that for any prime number P, P minus 1 factorial divided by P leaves a remainder of P minus 1. So P minus 1 factorial when divided by P leaves the remainder of P minus 1. For example, 16 factorial divided by 17. So this is your P. This is P minus 1. So this will leave a remainder of 16. This will leave a remainder of 16. And for any prime number P, P minus 2 factorial divided by P leaves the remainder of 1. So P minus 2 factorial divided by P leaves the remainder of 1. For example, this is the remainder as P minus. For example, 21 factorial divided by 23. So this is your P, this is P minus 1. And will leave a remainder of 1. It will leave a remainder of 1. Now, this is your Wilson's theorem. Now, according to Wilson's theorem, let us try to solve a few questions. What does it say? 12 factorial divided by 30. Will, this is P minus 1. It will leave a remainder of 12. And then 11 factorial when divided by 30. This is P minus 2. So it will leave a remainder of 1. It will leave a remainder of 1. Now when 10 factorial is divided by 30, what will you do? 10 factorial divided by 30. What will be the answer? Okay, let us see. And because this is P and this is P minus 3. So let us say, I know that 12 factorial divided by 13 leaves the remainder of 12. Correct? 12 factorial divided by 13 leaves the remainder of 12. Okay, 12 factorial can be written as 12 into 11 into 10 factorial divided by 13. And it will leave a remainder of 12. And 12 factorial is nothing but 12 into 11 into 13. Now 12 divided by 13, remainder is minus 1. 11 divided by 13, remainder is minus 2 into 10 factorial divided by 13 leaves the remainder of 12. It leaves the remainder of 12. ये minus minus plus हो गया. So 10 factorial divided by 13. ये अभी 1 into 2 it's 2. ये यहाँ पे आ जाएगा divided by 2 will leave a remainder of 6. So 10 factorial divided by 13 leaves the remainder of 6. Can you understand this thing? Okay. Understand this thing. Okay. Similarly, D question we'll try to solve. 16 factorial to the power 39 divided by 90. What will be the remainder? So let us first try to find out 16 factorial divided by 90. What will we do? I know that 18 factorial divided by 18 divided by 19 will leave the remainder of 18. This thing will leave the remainder of 18. Yes or no? Because this is P minus 1. Now 18 factorial can be written as 18 into 17 into 16 factorial by 19. and this thing leaves the remainder of 18. Now 18 divided by 19, remainder minus 1. 17 divided by 19, remainder minus 2. 16 factorial divided by 19. This is equal to 18. So this minus minus will become plus. And then 16 factorial divided by 19 will leave the remainder of, it will leave the remainder of 18 divided by 2, that is 9. So here we are going to get the remainder as 9. So what would be the case here? 9 raised to 39 to the power 19. 9 raised to 39 when divided by 19, what will be the remainder? Because 16 by 9, 16 factorial by 9 will give me the remainder of 9. Still, I will have 9 to the power 39. I will have to divide it by 19. So what is this? This is P. If, let us try to apply Fermat's theorem here. 9 to the power, this is 19, 9 to the power 18. This is your A, this is your P, this is your P minus 1. This will leave the remainder of 1. So 9 to the power 18 into 9 to the power 18, 36 over 9 to the power 3 divided by 19. This thing, according to Fermat's theorem, will leave a remainder of 1. This thing will leave a remainder of 1. 9 cube is 729 divided by 19. So 19 threes are 57. 729 divided by 19. 729 divided by 19. 19 threes are 57. We are left with, this is 5, this is 1, 59. 19, 95, 114, 133, 152. 8s are 152, remainder 7. So overall, my remainder would be of 7. Okay. And then the last question. Find the remainder when 1 factorial is divided, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial, up to 90 factorial is divided by 42. And all of this is divided by 42. So each term can be divided by 42. Yes or no? Now, 42 is what? 6 into 7. So as soon as I get 6 and 7 in a factorial, that term will be properly divisible by 42. So I don't get 6 into 7 here. So the remainder will be 1. I don't get 6 into 7 here. So the remainder will be 2. I don't get 6 into 7 here. So the remainder will be 3 factorial. That is 6. I don't get 6 into 7 here. So remainder will be 4 factorial. 4 factorial is 24. I don't get 6 into 7 here. So remainder will be 5 factorial, which is 120. I don't get 6 into 7 here. So it will be 6 factorial is 720 and divided by 42. All of this divided by 42. I'll start getting 6 into 7 here. So 6 into 7 will be available. So this term will leave a remainder of 0. 6 into 7 will be available here. So this term will also leave a remainder of 0. This term similarly will leave a remainder of 0 till here. So now I just have to check for this. So 1 plus 2 plus 6. So 720 plus 120 is 840. 840, 850. 850. No. This is 840. 840 plus 30 is 870. 870 plus 3 is 873. Divided by 42. 873 divided by 42 will leave a remainder of 33. And it will leave a remainder of 33. करके देखो 873 divided by 42. 20s are 840. Remainder 33. So here, if you apply the right logic, you will come to know that only till 6 factorial the numbers are not divisible by 40. Rest all the numbers beyond 7 factorial, 7 factorial and beyond, all the factorials will be divisible by 40. Okay, so by this case, you get the remainder as 32. So here we finish numbers 2. Now, if you have any query, regarding numbers, you can connect on any one of these three social media platforms or visit our website tarkashastra.co.in or send a WhatsApp message on any one of these two numbers. Thank you so much. Jai Hind.